Can you subscribe with like RSS on Twitch? That would be interesting. Anyway. Cool. All right, looks like we're live on YouTube. So let's get going. Now, sorry people are watching on YouTube. I've disabled the chat for now just because it's, I'm very, very bad at multitasking. So on our, I've just got the Twitch chat up in the top right. And because the HTTP API for interacting with the YouTube chat is kind of shitty, and I haven't written code to interact with it yet, I'm just keeping it like this for now, so sorry. Okay, so what are we doing today? We are working again on MPEG transport stream. This is a media container and kind of mushed in with a protocol that's used to do a whole bunch of things. Originally it was designed to, as it sort of looks like, transport MPEG, and specifically to stream MPEG around. So that means, for example, in like old school, I say old school, I guess not really, it's still current, but digital TV that's like transmitted from big, like antennas and metal towers. Digital TV, digital radio. And a fun fact that I feel like I should always mention now is in places around the world that had cable internet, cable like from cable TV, for example, in Australia we have Foxtel, Optus, what was it called? Austar. Often you'd have a coax cable coming in. Eventually they did cable TV, cable internet. And how cable internet actually worked was this thing called DOCSIS, and still, I think, around the world. But DOCSIS, the way it delivered the internet was actually had these DOCSIS frames in MPEG transport stream payloads. So the internet came in through MPEG transport stream, which is just wild. I don't think it works like that anymore because there have been new versions of DOCSIS since then, but I think the first one or two versions actually used MPEG transport stream to like transport IP packets around the place, which is just crazy. So what we're doing is we are, well, so far we're up to, what are we, day 4 now? We have decoded the main bits of the packet and the packet header. So in MPEG transport stream, we've got these things 188 bytes long, that's a packet. And it has a header, and then it'll have a payload, which contains whatever. That's how you're seeing this video, by the way, is we're doing MPEG transport stream from a computer here over raw UDP to another computer that's actually streaming out to, to the internet. Yeah, so we've done most of the header. So in our little structure, it looks like this. We've got a packet. We've got some flags that, tell decoders what to do, a bunch of information about it. And we also decoded the adaptation field. So this is another part of the spec that, contains things like clocks, basically just more information about the, just for now, we'll just say more information about the stream to help decoders actually decode the thing. Okay, there's one important part of the payload that I wanted to implement in our MPEG-TS package, and that is being able to decode and encode the packetized elementary stream packets. These packets are the ones that actually contain, the audio and video data. So within these PES packets, they have a structure that looks like this. We've got an ID, which is just like unique identifier. So you know what thing are you doing, audio, video, whatever. And you know, we've got a length, and then of course we've got a header, which then contains a bunch of other stuff. And importantly, it has timing information. So this is the thing that any sort of decoder will use to actually work out, you know, how to play the video, how to keep things in sync, how not to play the frames too quickly, too slowly. If you lose a packet, for example, like if it's a rainy day, or if there's a solar flare, or if, you know, who knows what happens, the decoder will be able to pick up at an appropriate place and keep playing. Important as well for syncing audio and video. When you scrub video as well, you're going to need these clocks. You're going to need these timestamps so that you sort of, you know, like when you go back, how to time stuff again. So that's why I wanted to decode these packets. Decode this type of payload. Yeah, so for the most part, I think we got it working. We need to do a little bit more testing on it because I'm not super confident. The other thing is we are not yet able to encode this structure. So we decode it out of its binary wire format, but we're not able to encode it back out again. So that's pretty much what we'll do today. And of course, we'll add a bunch of testing and stuff like that because that's kind of, otherwise, how do I say? This is the thing with this binary stuff, is because it's not text, because you can't just look at it and go, oh yeah, that like looks all right. It doesn't look like anything, right? It's just zeros and ones. So often it's a good little exercise to, well, it's useful because you write all this testing and then that also gives you tests for the future as well when you're refactoring. Sweet. So yeah, look, let's get cracking because that's what we're here for, right? Yeah. So, so we've made a new, oh, wow, this was a really cool project. Yeah. So actually, yeah, I have a, maybe I should tell a story about, so, I've kind of half done this. Well, I've kind of done this before. I did it for a project for a large TV broadcaster in Australia. And, yeah, whenever I watch the TV, and I see the video working, I think, phew, okay, the code is working. So, yeah, a really smart person sort of, I guess, gave me a quick introduction to MPEG transport stream. And there's basically a whole bunch of devices out there, smart TVs, set-top boxes, all of our like players, VLC, QuickTime, anything running on Android. They'll all be able to use, they all rely on the timing information in MPEG transport stream to kind of work properly. The thing is that we don't know quite how robust some of these implementations are. So some of these decoders don't work that well, basically. Some work really well, like for example, like VLC. If the timing information's a bit fucked up, like say there's errors in the packets, then it can kind of keep playing. But some devices are not that, like their implementations of MPEG transport stream decoding and subsequent like H.264 and video and audio decoding is not super robust. So the players can get confused if something happens. So one of the problems that was going on was, let's say a bunch of devices were found to be, let's say like very non-compliant, and the fix was basically when there's discontinuities in the video, or like in the stream. So for example, there's an ad break, or you know, the TV's turned off suddenly because like power's plugged or whatever, anything like that. When you're scrubbing, that's also discontinuous because you're stopping, going to a new place and starting again. Some of them needed extra help. And so that's, we wrote some, well, I say we, I wrote some software that retimed the video by sort of reaching into the packets, shifting the timestamps around, and then passing them straight back on again. And I spoke to somebody else who who was doing the same, had to do pretty much the same thing. I think they were in the Netherlands. I can't remember. But we were speaking to them on the chat here. It was, yeah, fun to kind of laugh and cry about it. Yeah, so it's an interesting, fun little kind of format. Anyway, yeah, so that's the kind of relevance of this, of the stuff that we're doing now. And it'll be good to have it open source so that other people can, you know, look at it and, you know, I think I feel like I'm learning a lot, and so hopefully other people are too. Sweet. Okay, so we have a test, and how the test works is we read in a transport stream file, and a transport stream file is literally just 188 byte packets, just all in a row. We read in the file, we read in packet by packet, we decode it, encode it again, and then just, yeah, write it back out. And then we check, hey, like, is every single byte bit for bit the same? So far it's telling us that it actually is, which is weird because we haven't, I haven't written any code to encode our PES stuff. So that's probably the first thing I want to look at, is just trying to understand like whether I'm doing something really dumb there or something, and see like, I don't know, it's yeah, it's weird. Yeah, so let's have a look. So we have our, am I streaming, Haiku asks, am I streaming tomorrow? And if so, what time? Yeah, I should, Thursday, yeah, should stream tomorrow. Probably from, I'll do UTC time, just so everybody knows. So we're gonna go from maybe the same time tomorrow, maybe from 3 or 4 a.m. UTC to, yeah, I don't know, maybe 6 or 7 hours or something. Hey there. Yeah, I actually did disable the YouTube chat. Sorry. Just a bit hard to concentrate on 2 different chat windows at the same time because I can't multitask at all. So yeah, if anybody knows of a nice YouTube chat HTTP API library, yeah, then I'll be interested to yeah, look at that. And you can, if you like, you can send that to the mailing list. That would be super helpful. Thanks. But if not, it's cool. Yeah, yeah. Okay. So in our, what we do in our decode function is we make a buffer of 188 bytes, which we know that's the fixed, exactly the size. And yeah, we're going to read it in. This is super inefficient, by the way, like making a new buffer all the time, but you know, we can get to optimizing it later, right? And we go down, we read all the header, so we read all of this stuff in. We decode the adaptation field if it's there. And then we've added a new block here to check and see, hey, is there a PES, yeah, is there a PES packet in there? And if there is, then we decode that and we store it in our structure. Oh, fucking hell. Huge cockatoo just landed at the window. I should actually show you guys that, because I don't know whether are they native to Australia? Yeah, let's have a look. Oh, is it going to get scared? He comes here because they like, sometimes we give him little bits of muesli. They're super loud and, oh, there he goes, see? He knows how to get food. He literally taps the window. Yeah, you fat bastard, to give you enough food. Oh, there, you can hear him, listen. Oh yeah, no, he knows, yeah. They're smart. That's the federal bird infiltration, right? FBI. Hey. Yeah, there you go. Oh, the focus isn't quite right. Hold on. Oh, he's a bit cold. Hey, stop trying to eat the wood. Yeah, you hear me. Greedy bastard. Alright, I'm gonna go. Alright, let's get back to work, shall we? Okay. Oh yeah, cockatoos? Oh, there's so many here. Oh yeah, the link to the project is there we go. Forgotten about XS. I will get back to that, but I wanted to finish this MPEG transport stream first. Yeah, that will be fun. So what we'll do is we'll do MPEG transport stream, then we'll do RTP, and then we'll do JPEG XS. Because you can transport MPEG transport stream in RTP, and you can also put JPEG XS in RTP as well. So what I'm thinking is we'll do MPEG transport stream first, just to make sure our RTP thing works, and then we can do JPEG XS. That's my thinking. All right. What is hey. Called. Hey, yeah, there he goes. He's gone. Okay. JPEG-XS is a low latency low latency, low implementation complexity video codec. So it's designed for use in basically to replace SDI, which is kind of like HDMI. But it's meant to be, it's being sort of pushed as the replacement so that you're able to transport like pretty high quality video over IP. So like over Ethernet cables or something like that. It's a codec that's like meant to be really easy for like even like like very low powered devices to be able to decode. What's a GitHub project on check wildfly free about? What was it again? That was just a little that was a tool that I wrote many years ago now. It was a monitoring project, and that was one of the little tools that needed to be made. I can't, what is, yeah, it checks Wildfly, which is people know as JBoss. It's like Java Web Application Server thing, kind of this horrible thing. And it just checks the can't remember what. I think all it did was just like read the current like heap memory usage of the JVM, something like that. Okay. Okay. Cool. So let's go for our decode pairs. Yeah. I see why it's working now. Okay. Yeah, okay. Okay, I know why our test is passing. Our test is passing because we're still storing the whole entire we're still storing the whole payload of the packet in our byte slice. So if we go to packet, the payload just contains everything else that's not this stuff. And we're just storing it as raw byte slice because, we don't really care about decoding it. Except PES is the exception. The thing is that we decode the PES payload, and we store it decoded, but we're still storing it also as a byte slice in here. So that actually makes sense. Yeah. So what we could probably do is perhaps modify it to, really not do that. No worries, Haiku. Thanks, yeah. Likewise, keep up the good work. Sorry I couldn't go into more detail about that check wildfly free thing. Just, as I said, I'm very bad at multitasking, so. Oh shit, I just realized that let's go. There we go. So I just realized that the stream died there. All right. Okay, yeah, so as I was saying, we can see why it's still working. So let's go to our encode function. Okay. let's start to encode this thing. So we're going to need the spec. Okay, here we go. Okay. Let's have a new function in, let's go down, let's do a, all right. So we're going to start with a, okay, pretty easy. We can just start with a buffer of 1, 2, 3, 4, 5, 6 bytes. Let me put that over here. And then actually let me do this. Yep. Put that here, there. I'll just do it like this. Okay. Okay, let's make a buffer, make a byte. 1, 2, 3, 4, 5, 6. Let's do a little, I can do 3 plus 1 plus 2. Just a little comment. Length is the start code plus ID plus length. Okay. And then we want to get the 3 bytes. No worries. See you in a bit. I think we actually have this start code prefix on. Yeah, pes header prefix. There we go. That's easy. Okay, so what we'll do, we'll just copy that into our buffer. So copy into, so 3 bytes, so we go 0, 1, 2, so there. Our pes header prefix, and we just turn it into a slice just because we're storing it as an array, because it's only 3 bytes. Okay, next up we're going to get the store, pack in the stream ID. So that's just 3 equals the p.id. Here we go. This is where I'm getting the information from. And then the length. So we've got a uint16, so let's just encode that big endian. We can use this function, put uint16. So we're going to put our uint16 into the slice 4 to Your names don't match with YouTube. I don't know there was a Twitch button. Spend a while looking for Twitch. Yeah, sorry. Yeah, yeah, so is it like if I go onto YouTube, I'll just quickly deal with that. So this is when you go here and then it's okay. That seems to work okay for me. I should probably put a little link in the little ticker down at the bottom, shouldn't I? Saying, you know, for chat, see Twitch or something. Would that be useful? Yeah. Okay. Yeah. Okay. Cool. Hey, thanks for spotting that. I can do that right now, actually. Like that? Okay. Yeah, I gotcha. Yeah. What do you think of this now with the little which way? Like down here. Is that do you think that's clear? Just link on the title. Oh, yeah, okay. Yeah, okay, maybe I'll put it at the top of the description. Okay, I gotcha. Yeah, okay. Let me write that down to do that later. Cool. Okay, thanks. All right, let's get going. Chat Acme, yeah. Okay, let's get going here because it's too long. Okay. So we've got our PES packet. We're going to put this length into the index 4 to 4 to 6, right? And that's going to be our p dot length. Okay, so that's that done. Okay, now let's encode the header. We need to check if it's nil. I don't think it... Oh yeah, it can be nil. Okay, so let's go if not equal nil. Okay, let's go in and that's encoded. Okay, that's this thing here, which we have here as well. I feel like I want a new function for this just because, yeah. Let's do another byte and error. We may not need to even return an error because it's, but yeah, we'll see. Okay, so we're gonna make, let's make a buffer. We know the size that we can make it initially. So it's gonna be 2, 4, 5, 6, 7, 8. That's 1, 2, 3, 4, 5, 6, 7, 8. It's 2 and 3. So now we can make it up 3 bytes first. Just do a comment here, so it's going to be going to do the flags plus fields plus header length. Okay, so it just explains the actual value there. Okay, so we've got our, okay, so the first 2 bits need to be the OX first 2 bits. So that's going to be, so OB 1 1 1 2 3 4 5 6. It's 1 0 binary. So it's really going to be OB 1 0 1 2 3 4 5 6, like that. Okay, that's our marker. Let's just call this, so we'll call it okay, the scrambling, I think we can just, yeah, so we'll just do it straight up. So scrambling. We can just toggle the bits because we're just storing the bits just normally here anyway. Okay, now we need to do the priority. So if the header priority flag is set, there are no bit fields in Go, unfortunately. No. Yeah. Yeah, so that's the, yeah. So yeah, exactly. We need to store those 2 bits in a uint 8. This is 1 shifted to the 1 2 3 4 5. I can't read anything. Chat's were disabled in YouTube. It's hard to. I was just finding it difficult to concentrate on 2 different chat windows at the same time. Okay, yeah. Sorry, yeah, I know. It's a bit, the issue, I guess, is that it's like if I can just have a single, like a single sort of window of text that contains both the YouTube chat and the Twitch chat, then I'll be very happy. If anybody knows of any YouTube like chat API client library, then yeah, send it into the mailing list. That would be super helpful. Seven, 6, 5. So this is 4. And then we just keep going down. Priority alignment. Okay, so if h dot alignment, then we toggle the next bit. Three. Okay, I think that's that byte done. So those are all of our flags. Okay, so next we're gonna see what the optional fields are. So this is just okay, how are we gonna do this? Timestamp. Okay, let's go down. Let's go if h.timestamp. So if it's set, then we can pack the timestamps. This is going to be basically this bit is going to be a real pain in the ass. Okay, so bear with me. It's going to be tricky again, I think. Yeah. So we've got a new. Actually, yeah. Okay. Let's do this bit first. So if the timestamp is nil, then we're gonna now toggle these 2 bits. I will see how we need to toggle the bits. Okay, so we go if h.timestamp.pts. All right. Then we say we toggle that first bit. So buff1 is toggle with that first bit. Okay, and then if we're going to keep going. So O1 is forbidden, and then 1.1 is DTS. Okay, so now we're just going to go if, whoops, DTS, and the same thing. 1 is toggle the next bit along, which is like that, and then now there is actually some error checking we can do here, because we can say, well, it's invalid to only have, so let's actually put that at the top. So let's say if not h dot, so it's invalid to have the presentation timestamp. Sorry, it's invalid to only have the decoder timestamps as DTS. Then we need to return. This is a bad timestamp. DTS set, but without PTS. Yep. Cool. Okay, and we return early, and then we can just move on. Okay, cool. Let's keep going. So we've look at this. I'm not storing any of these other things. I'm going to have to store these values because otherwise I won't know how to, you know. Okay, a couple ways to do this. So one way is I can store it as a uint8 and just not care about these things. So for example, what I could do is I could just have here fields and then as a uint8, or I can store them all store them all as booleans. I feel like I want to store them as booleans. It's because it just feels clearer to me. It's a bit of extra work, but I think it's clearer. So trick mode. Additional copy info. CRC. Okay, something like that. Or really could get, or we can store it as fields and then maybe from here have like a I'll put that over there. Have like a fields like some constants that just tell you. So it could be something like has PTS 1 shifted to 7. 1 and then 7 minus iota. No, wait. 7 minus like that? Is that it? Yeah. Yeah, but you get the idea. So DTS. Yes, CR. Yes, right. So trick mode. Let's copy info. Seven, 6, 5, 4, 3, 2, 1, 0. No, that's not right. I'm missing. Two, 3, 4, 5, 6, 7, 8. Trick mode, copy info, CRC extension. 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, that's right. Yeah. And then here we could have flag, you know, maybe flag PTS, something like that. Flag field PTS. I don't know. I don't know. I feel like, yeah, look, I'm going to store it like the fields like this. Because, yeah. And then we have the values here. So go like flag, flag PTS. So replace all of that. Yeah. So fields, you know, they are present in optional. Okay. And then that will actually be up here. Timestamp, yeah, okay, we already, that's good. So now what we're going to have to implement is the storing these flags. So when we decode a pairs header, before we weren't storing we weren't storing these values, but we do want to do that. Okay, so decode pairs header. Okay, here we go. Fields, all right, here we are. Now, it should be pretty easy because it fits into a whole byte. So we're just going to have to go here. That's pretty easy. We're going to go fields, which can actually just store it as let's do h.flags. Where's fields? Okay, we do that, and then we go h.fields equals buff1. Yep. And flags is there, so there we can actually go like that. All right, so we go read from the first byte, second byte there, and then let's do that. Okay, cool. And then we're going to h.fields. Let's rename these to fields. Okay, let's grab that and put that somewhere. Up at the top here probably. So we've got fields there. Maybe field. Yeah. Okay, field. Okay, there we go. And now we can actually do something more useful. We can say h.fields and field PTS. Same as this, field PTS and then field DTS. Now that is clearer. Cool, that's nice. Oh, sorry, I just realized we're missing the chat messages. As I said, I'm very bad at multitasking, so. Okay, you have changed agnostic. Are there bit fields going? No, I know they exist. See, I don't, why would chat stuff on YouTube? Yep, I'm really curious. I'm really curious if we're in 1999, 1990s. First your browser scenes from the 80s, and then your IDE, I'm lost. No, this is the modern version of Firefox. Okay, 124, I think that's pretty new. No one knows it's going except for you. The left shift has priority over or equals. Over the toggle. Think so. Oh, no. It's because I've got it in the parentheses. What's the end goal of this project? That's a good question. Look, basically, I had done a bunch of stuff. I've done a bunch of this stuff for, like sort of work projects. And I figured I would, basically just try and, I think, to do it publicly, open source. I've learned so much from other people doing this kind of thing, like open sourcing stuff and developing stuff open source. So, really that's kind of it. Never done go anything level, so why not use size of uint64 instead of 8? That is actually a really good question. I think, can I do that? I do a length? I don't know whether there is a, I don't know if there is a size of in Go. Oh no, maybe I can do the type. That's a really good question. Yeah, let's have a look. That would actually be really nice. It seems so obvious now. I can just do input. Mine is a var. Okay, yeah, I can't do that because it's not like a slice or anything that has a length. Yeah, okay. Well, is there somewhere else built in? Type by. Maybe there isn't. Yeah, I don't know whether. Yeah, I don't think Go has a size of. Yeah, there we go. There is unsafe.size of. Yeah, that's right. Yeah, in the unsafe. Yeah, I remember that now. Yeah, that's in that book actually, which I have somewhere. Yeah, but okay. I mean, I'm not going to import the unsafe package, I guess. What is my OS? This is OpenBSD. Yeah. Okay. I need to update actually. What? Am I not running? What? Am I still running 7.4? Shit, I haven't upgraded to 7.5. Weird. Long-time FreeBSD user. Yeah, cool. I keep parentheses for clarity even they are not strictly needed. I don't know. I don't know. I feel, I'm not sure. I haven't really thought about it that much. I guess sometimes I think it's kind of a little bit clearer maybe. But I don't know. Yeah. We could try refactor and see like if it, yeah. Yeah, nice. Yeah, I've actually never installed FreeBSD on like a desktop, Tried it a couple of times on servers, but never on a, yeah. Drivers are terrible. Just use it on servers. Yeah. Okay. Yeah. 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 I heard that. Yeah. There you go. I mean, the drivers are. Actually, no. Don't the doesn't FreeBSD import the Wi-Fi card drivers from OpenBSD anyway? Apple Broadcom drivers. Yeah. Okay. Yeah. Those Broadcom drivers have always been a pain though, haven't they? Yeah. I remember even the Broadcom driver, like I remember I had a Broadcom PCM CIA card for my laptop like years ago in 2005 or something, I don't know. And yeah, and that was running, was that Ubuntu or Debian or something? And oh God, I remember because I was pretty young then. And so I was really out of my depth trying to get the Broadcom drivers working for that Wi-Fi card. Yeah. Okay, so let's go. Yeah. Sorry, I've lost my place now. Where was I? I was storing the fields. So I stored those in. Oh yeah, here, yeah, so fields. Yeah, so we store them, okay, cool. And then we decode the timestamp if it's there. So that's really the only, yeah, the other payloads we don't. No, that's fine. Okay, cool. All right, so so when we're encoding again, now we can actually write out the, all right, so now we can just go of our header fields. There. And we don't need any of that then. We can do some validation there. Okay. So we've encoded the, actually I don't think we need to do a type conversion there. All right, let's pack our timestamp. So this is going to be a bit of a pain, especially for a noob like me. Okay, let me grab a new copy of this. Let's pull this out because we're going to need a bit of space here. So the timestamps are encoded in this. A timestamp is where's our timestamp structure? Here we go. Let me change it to monospace just so we get the bit diagram right. Okay, our timestamp is here. So this actually is holding a 33-bit integer, which is fine. That's no worries. I mean, it's a bit of a pain, but okay. And then we've got some flags here as well that are actually stored. So when we pack up a timestamp, it needs to look like this. So we've got these 2 bits at the beginning that are reserved. We've got those 2 flags. So that's the, so we toggle this bit if the timestamp is a PTS. We toggle that bit if we've got a DTS. And then we start packing in our 33 bits. So we start off with 3 bits, and then we have to have 1 as like kind of like a check bit. I think was the word that somebody used the other day, which is a good word. I'm going to use that. But yeah, that's just the rule. We have this bit just set to 1. Then we pack 8 bits. Then we pack 7 bits and then 1. Then we pack 8 bits. Then we pack 7 bits and then 1 bit. So here's the code that unpacks it from this. Oh, fuck. This is the code that unpacks it from that sort of that binary representation. Now we're going to need some code that takes our timestamp and then packs it into this structure again. Yeah. Okay. So let's give it a go. Might be able to just have it in a separate function for now. We might even put it here. And then we know that it has to be an array of 5 bytes. So we'll just do that, just, you know. Okay. Let's have that. All right. Okay. So let's do our first, the byte at index 0. So we're going to start here. So if our timestamp has the PTS, then we do O, so shifted 7, 6, 5. Okay, and then now we set the next bit. If DTS, all right. So this is here are these like the array index. So we're working at 0 now. Okay. Yeah. So we've got our ticks stored as a little endian, uint64. So, yeah. What we could do is we could turn that our little endian uint64 into a binary. Oh no, sorry, and yeah, turn that into a. We could encode that into binary in a little buffer here. So we could say, you know, let's just call it B, right? So is it make a slice of 8 bytes. Like that. And then we can encode, put our uint64. So we put our uint64 into this slice here. So what's our thing again? Our t.ticks. Okay. Now we know that 33. Yeah. 2, 3, 4. Okay, so now we know we've got our 33 bits in this slice here. We've got it from Lizzie Rom. Hey, how's it going, man? Can't stay long. They're making me write Python at work. I had to spend the last 4 days, including the weekend, studying. Oh man, that's sorry to hear. Yeah. Yeah, things are going fine, I think. Yeah. Hope things are going okay for you too, man. That's yeah. Hope it works out. Hope it works out down there in Florida. In our what do we call that? In Australia, we're the deep north. You're in your deep north equivalent part of the world. Oh wow. And wrote Python in 6 years. Yeah, nice. Well done. Yeah, it's hard, hey, like yeah. It is like a groove thing though, isn't it? Like you sort of I remember I was doing JavaScript for like a year and then I needed to go back to it was like, oh, we just need this really quick project, like, you know, just a couple of weeks, but it was all in Python. And I was like, oh, what? And it was, those first few days is really hard. But afterwards it was okay. It's hard. And hi, Mr. Streamer. I have a question. Am I great at Windows crash code? I don't know what Windows crash code is, sorry. I know how to crash Windows, sure. But yeah. If you send a link through or something, or if you've got any questions, email it through to the mailing list maybe. So that's our it's down in the bottom corner somewhere here. Wait, which hand is that? This one? Yeah. I have frequent interrupt exception not handled. Oh, like that. To crash window. Yeah. Okay. I'm not sure, Mr. P. Ramadan. Hard to say without the source code. If you want to write like a bigger example and send it to the mailing list, then yeah, maybe we can help out. Okay. You remember done? Yeah. Yeah. Nah. This is we've swapped over to OpenBSD now. JB Pratt, which is good. Because this is the computer that I normally use, so it's nice to... Yeah, I know, finally. Yeah. Yeah. Yeah, because this is the computer that I always use, so yeah, it's nice. Okay. I'm gonna get back to this timestamp packing because it's a bit involved, and I don't want to... Otherwise, I'll get confused and forget what I'm doing. Whoa. Yeah. No, it's cool. No. Hey, thanks for stopping by. It's super kind. Yeah. Okay. Yeah, see, fuck, I've already forgotten what I'm up to. Oh, yeah, no, okay. So in our byte slice here, so in B, we have 33 bits that we care about. Now we need to pack these 33 bits into this structure here. So what we're going to do is we're going to get the first 3 bits and put them into there. So how are we going to do that? Let's get let's do this as ticks. Okay, and this is like the encoded ticks. Let me draw another diagram. I'm going to do that here or somewhere. Let's do it. Let's do it here. Okay, so it's going to be the same again. So 1, 2, 3, 4, 5. Yep. Okay. So that's 4 and 3. Okay. And then 1, 2, 3, 4, 5, 6, 7, 8, 16, 24, 32, 31. Okay. And those are 1, 2, 3, 1, 2, 3, 4. Okay. This is the value that we've got in ticks. So this is ticks. Okay. So we're going to want these 3 bits. We're going to want those 3 bits, but then we're going to put them, god damn, this is, okay. This is what it looks like when it's packed up. All right, so let's go. Okay, we're going to get these 3 bits and we're going to put them into here. So that's going to be we only want those 3 bits though. So we're going to do a bit mask for that. So, and of course I always forget my bit masks. So, hex tables. It's so funny. I love this. Like almost every day I look at these tables and every time I forget them. There we go. Actually gonna save this, hold up. Actually I can just do alright, what do we need? Did that just not go? Save. Okay, weird. Maybe it's not actually a PNG. Anyway, okay, we got that there now. Oh, fuck, no we don't. So we want the first 3 bits, so that's going to look like OXE0, right? Okay, so that's our bit mask. OXE0. So we've now only got these 3 bits. and we want to toggle those here. So AO toggle the value from B, like that. And we could probably do this in one line, there, like that. So we got those 3 bits out. Okay, we've got those bits left to go from that byte. So now we need, okay, finally then we toggle, the rule is that we have to toggle that bit. So let's just do that. That's just 1. Check bit. I'll just say toggle the check bit. That's the name that somebody used for it the other day. Was I can't remember his name now. Was it Irving? But Irving was super helpful and very knowledgeable about this sort of thing. So yeah, it's cool. So these are the leftmost 3 bits. Oh, no. Look, I've already fucked it up. That isn't right. I've grabbed these 3 bits, but I need to put them there. So I need to do a bit shift. So I need to shift, oh man, okay. So I need to shift them along. So that's implied, but then I need to put them into this position. So I need to grab those 3 bits and shift them along. 1, 1, 2 positions. All right. Right. 1. No, I need to go many more. No, so I need to go shift once. I need it to be, we've got 3 bits here, so we need to put those 3 all the way over to here. So that's 1, 2, 3, 4. Shift 4, I think. Yeah, I think that's it. Oops. Ah, there we go, that's better. Yeah. One, because I need that bit. So I really need that bit to be here. 1, 2, 3, 4. Yeah. Okay. So AO equals B shifted to the right 4. There. And then we toggle the check bit. Fucking hell. Okay. And now we go, okay, and now we're gonna, let's toggle all of those bits somehow, which we can't do. So let's pack the next 5 bits. Okay. Let's say pack remaining 5 bits. Oh. So we've got 5 bits. How do we put them into here? So the value that we want to work on is B. Let's just use B again, just because it's a single byte that we're kind of working with. And the bit mask here is going to be that stuff. So that's OX1F. Okay. And we need to put those 5 bits into here. So we could do that by shifting those left 1, 2, 3, right? Because then that bit is going to be here, which is what we want because we're going, yeah. Right, shifted 3 to the left. Oh, man. Oh, yeah. No worries. No worries, Mr. P. Ramadan. Thank you. And good luck with your GPU and your Windows crash problem. Sorry I couldn't help. Just busy doing this thing. But yeah, all the best, mate. Okay. So we packed 5 bits. All right, 1, 2, 3, 4, 5. Yeah. Okay. There's 3 bits pack. There's 3 bits remaining in A1 at this point. So let's grab 3 bits from our ticks. Let's put that in. So we're going to go A, yeah, we finished with that now. So let's go, and we're done with ticks O. Okay, so now we go ticks, done with ticks O, so get 3 bits from leftmost, 3 bits from ticks 1, okay? So ticks 1 is again OXE0, right? And then we want to put them in the 3 right. Fuck, this is so confusing. We're going to put these 3 bits into here. So let's do that. We're going to do a shift right. 1, 2, 3, 4, 5. Right. So let's separate these out. So each one, okay. A1 is packed. So we finished with, yeah, because we've filled up A1. So let's move on to A2. So we want 7. Well, yeah, let's see how many we've got in. So we've got 5 bits left, okay? 5 bits remaining in, oh yeah, pack remaining 5 bits into A2. Okay. So this is going to be, we want from ticks 1, 1, 2, 3, 4, 5. So that's OX1F again. Hold on, have we done this? Yeah, no, all good, okay. And then we're going to assign that with some bit shifting to A2. Now we need to do a shift because we need those 5 bits starting here. So we've got A2, right? And then we're going to go shift it 1, 2, 3 over to the left. Which is actually the same as what we did above, but yeah, it's just... Okay, we've filled up those ones. Okay, now we're going to pack 2 bits in. Okay, so ticks 1 is done. So 2 bits remaining in A2 before the check bit. So we're going to pack 2 bits from ticks 2 into A2. Yeah. Okay. So pack 2 bits. Ticks 1 is done. Okay, so we're just getting the next 2 bits. So that's OX. Well, it's just, we could do OB 1, 1, 1, 2, 3, 4, 5, 6. So I mean, I don't know whether we need to do it like that or whether we should do hex, but anyway, we've done it like that. It's almost clearer using the binary just because, like, we can sort of see, you know, oh, there's 5 bits there, you know, 1, 1. Might actually swap these around to using binary notation. I think that's clearer. Because then you can visually see how many, like, which bits are remaining and stuff like that. I'm gonna have to think about the bit masks. So we've got these from ticks 2, and we want to put them into here. So we're gonna shift that 1, 2, 3, 4, 5. So B is shifted. Let me just check again, because that's our value of B right now. 1, 2, 3, 4, 5. Yep. Okay. And then we toggle the check bit. Okay. We've got all these. So let's get the okay, so let's do B ticks 3. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2. A2 is all packed up, so we can just assign the 6 bits remaining in ticks 2. So we've got, all right? Yeah. Yes, it's going to be the opposite of that. Yeah. So ticks. Whoa, no, hold up. Why is it ticks 3? No, it's ticks 2. I haven't finished ticks 2. We're going to put that into A3. 1, 2, 3, 4, 5, 6, okay? So we need to shift that along, shift that to the left 2. So A3 is B shifted to the left 2. So we're going to get those 1, 2, and then pack it into A3. Yep, that's right. Okay, cool. Okay. Oh, fucking hell. Okay. B now is 2 and B like that. That's what we've got left over, and then we want to pack it into A3. 2 bits into A3 apparently. 1, 2, 3, 4, 5, 6. So we just put it into those 2. Pretty easy, I think. Is that right? Do they align? This is wrong. I've done this backwards. So we've got the ticks. Yeah, I've got this wrong here. So ticks 2. We packed those bits. Yeah, so it's like this, 0, 0. That. 1, 2, 3, 4, 5, 6. Yeah. So A2 is, yeah, that there, like that. That's correct. That means ticks 2 is all done. And A3 has 2 left. Okay, so let's just write it. Ticks 2 all packed. So ticks 2 is packed. Oh, yeah. A3 has 2 bits remaining, I think. Yeah. So we need to get, so this is now ticks. So this is wrong. This has got to be 1, 1. 1, 2, 3, 4, 5, 6, right? Because we're reading from ticks 3 now, we're reading from here. Because we've done all of that. We've packed all of this. We've packed everything. We've packed all that. So the next is we've got that because we've got 2 more slots free in A3, apparently. Because we've done, yeah, because we've just packed up all of that stuff. So we need to pack, yeah, so we need to get it into these 2 slots. Okay, so we've got 2 bits all the way over there. We need to pack it over here. So do it over in our diagram is ticks 3. 1, 2, 3, 4, 5, 6. Because I'm shifting right, I guess I don't actually have to do the bit mask. Because I'm shifting from all the way over there, so, but anyway, I'll just do it there for consistency, I guess. Ticks 3 is all packed. Okay. We've got A3 is done. Okay, so we've got just, okay, 1 more byte in our array to go. That's 6. So we can, I think now we can just, we've got, where are we up to in, so A3 is all done, right? So where are we up to in ticks? We've read the first 2 bits, so we've got that left. And we've got an open, yeah, nice, holy shit. Okay, okay, this is actually gonna work. I'm pretty sure this is actually going to work. This is ticks 3. Okay, those are the remaining bits. And we need to pack that into A4, down into here. So we need to put it into those bits. So that means we take this and we shift it to the left 2. Okay, just 1 bit left remaining in just one bit left to pack from ticks 4. Woohoo! Here we go. Okay. And then there's just one bit remaining, just one bit free in A4 before the check bit, right? So that's here. So we're going to pack that bit into that bit there, and then fuck me dead, I think we're done. Right? Because it's just that, so it's just that bit. And then we go A4. We're gonna pack that into, Jesus. No, let's get this right. So A4, we've got one bit and we need to shift that bit all the way to there, to that position. So that's 1, 2, 3, 4, 5, 6. I think that's it. I think we got it. Okay. Oh God. Let's test the packing of it. I feel like this deserves its own little test function. So let's do that. And it should be pretty easy to do, right? Because what we're gonna do is try and pack that, like the maximum possible ticks. So package MPEG-TS, import whatever. Okay, so the timestamp is the timestamp.tstamp is a timestamp, and we're also going to have both all of them set as well, just because why not? So is PTS is true, DTS is true, and okay, and the number of ticks is going to be a uint64, which is like the maximum value. So that's the maximum. What's a maximum 33-bit integer? How can we represent that cleanly? We can just do. We can do a hex notation, right? We can do 33 bits, so 0x01, and then, so that's, and then now we do 32 toggle bits, so 4, 8, 12, 16, 20, 24, 28, 32. I think that's right. So we could actually, I would actually like to store that value. That's actually, and in fact, if that value isn't recorded somewhere, then we should. Let's call it somewhere like here, const pairs header prefix. That should be a timestamp I want to put down here. Okay, and then I'm going to do const max ticks in 64 equals I want anybody who's good with this sort of bit stuff. I feel like there's a cleaner way to represent that. Like, can I do a? I feel like there's a. I don't know. I feel like there should be a better way. But anyway. Okay, max ticks. It's better. All right. Now we can do something like we've got our timestamp and then packed equals pack timestamp of tstamp. Okay, now we're going to do if pack does not equal okay, we're going to do this as an array of bytes. And we can do this very, very, very badly. This is how we're going to represent it. We know that the value that we want is actually every single one of these bits toggled. So it's going to be OBOO11 and then, right, 1, 2, 3, 4. No, is that 6? 1, 2, 3, 4, 5, 6, 7, 8, right? And then we just do all the way down. One, 2, 3, 4, 5. Now another really good test will be 0. So we'll do that afterwards. Okay, and then now we can just check. And if the pack does not equal 1, because it's an array, we can just check that. Like we can just check that with the equals operator in Go, which is very handy. Because it's just a value. It's not like a. Yep. The pack timestamp, we got the value of packed, but we wanted that. So tstamp packed, but we wanted that. Okay, we ready? Oh, max ticks is undefined. What? Fuck. Okay, we didn't get it. We really didn't get it as well. Shit. It seems it's all right. We got it. We got it. Let's do hex for these. Okay, let's read. Okay. So look at our diagram. Okay, start from the top. And we can just go, you know, like byte by byte. So actually in our test, let's actually log each byte. Packed. So we can just go if packed I not equal the value that we want, and we can just do this byte and then D and go, and then we can say, so we got, let's print out the binary, and but we wanted that. So we got the packed value, but what we wanted was that. Okay. Yeah, nice. Okay, look at that. That's beautiful. Oh, I know what's happened already, I think. Yeah, I think I know already what's happened is that, anyway, that's fine. We can, I didn't, I think this at the beginning is wrong, but let's just check that the logging looks is clear. So we got that, but we wanted that. Yeah, okay. All right. Yeah, see, all here we've only got, yeah, okay. I know what's going on. So our ticks here is actually wrong. We want the ticks to be, because we haven't sorry. In here, in these 8 bytes, we've got a 64-bit integer. But what we actually want is the 33 bits. But we've started from 0. But that isn't where we want to start. We actually want to start at we want to start from index 3. So what I mean is that because we know 100% that in our bytes, because we've got 64 bits, and we want to throw away 31 of them. So that means that the slice is going to be actually from 0 is irrelevant, 1 is irrelevant, 2 is irrelevant, 8, 16, 28, 16, 24, 30, yeah. So it's got to be from 3 onwards, like that. No, 0, 1, 2, from 2 onwards, sorry. No, 3 onwards, yeah. Yeah, because those gone 0, 1, and 2 just get thrown away. Let's try that. Fuck. Oh, my bad. Like that. Oh, almost. See, almost got it. See, only some of the bytes are wrong now. Okay, so let's, yeah, almost got it. Yeah, almost there, exactly. Final PR push on the night. Oh, nice, good work. Geez, hey, wait, what time is it over there? It's late, right? Like really late. It's 3 a.m. Yeah, okay, yeah. Oh, okay. Oh, well then whatever. Then stop fucking complaining, mate. Oh, in Dubai, yeah, right. Let's do this the way that we have done it. So in our, are we all behaving ourselves? Fuck, no fucking way. This is, something's not behaving right. Nah, we're actually, we're close. Ah, fuck. Okay. Sorry, I need to, okay. We want to read, yeah, this is already wrong, right? We want to read the, we want to pack 3 bits. Oh no, sorry, yeah, so it's OB, yeah. So we want these bits out of ticks. So that's 1, 2, 3, and then 1, 2, 3, 4, 5. Okay. So let's get that. So we've got those 3 bits, but where we want to pack them is over here. So we're going to grab the 3 and we're going to go 1, 2, 3, 4. Yeah. And then we toggle the check bit. Pack the remaining 5 bits. Okay, so let's do it in a bit diagram. So we've done 3 and we'll go 1, 2, 3, 4, 5. So there's our 5 that we want, which is the inverse of that. Okay. Now, we're done with tick 0, so pack leftmost bits from ticks 1. Yep, okay, so let's do this OB. Leftmost bits, apparently we've got 3 bits remaining in A1. Okay, so that'll be those 3. Because we've already packed in 1, 2, 3, 4, 5, yep. Okay, so let's go. We're done with tick 0, so pack leftmost bit from tick, so 1, 2, 3, and then 5. I'm still not so sure about the this big ending thing, but that's okay. Let's just check all this stuff. Ticks 1 and OX1F pack remaining 5 bits from ticks 1 into A2. 1, 2, 4, 5. Pack remaining 5 bits from ticks 1. Oh, this is impossible. I'm doing this wrong, right? No, this is wrong. I'm shifting left 3, but I'm losing my values then. Or am I? I need this diagram. Remaining 5 bits from ticks 1. So that's those values. So I need to mask those off and then go 1, 2, 3, 4, 5. And then we've got that, and then and then we can safely shift left 3 because we're just going 1, 2, 3. So that's fine. So that's okay, we're allowed to do that. B ticks 2. And then we're done with ticks 1 indeed, yes. Okay, so then we've got 2 bits remaining in A2 before the check bit. No. We're done with tick 0, so pack limits. Yep, okay, A1 is all packed. Okay, so we're moving on to here. Pack. So now we read from ticks. 2 bits, no, it's 2 bits remaining in A2 before the check bit. Is that correct? A2. Yep, okay, so we want to pack something into these slots here. So where are we up to in ticks? We've got that, yeah, okay, so apparently we can shift right 5 positions. I mean, to be fair, that's not really where our problem is, but let's just review it. So OB 1 1 and then 1 2 3 4 5 6. Ticks 1 is all done, so we're just up to here. Yeah, so we're going to get these 2 bits and slot them in there. Get 2 bits. 1 2 3 4 5. Yeah, and then toggle the check bit. Six bits remaining in ticks 2. So we do get these ones. Oh, byte 4. Fuck, that's totally wrong. Oh yeah, I forgot to toggle the last check bit. Let's do that first. Yeah, nice. Okay, great. So actually the only... Okay, so we've only got problems up at the top here. So let's actually focus on that. And then after this, we can also write another test. We can do another timestamp value. That's a good test, but we'll do that afterwards. Because yeah, I've got to work out this logic first. So I've got something going on up at the top here. So we've got byte 0 and byte 1. We're not getting the correct values. So we're doing here, byte 0 and byte 1. So apparently we're not getting something. In byte 0, let's focus on byte 0. So that's all the way up at the top here. The value we got is 0011, 0001. So that means we've got 0011, 0001. So these are 0, which I'm surprised by because I thought that we've set this to be a big fat fucking, you know, a very large number. As in the max ticks. So I'm thinking that all of those values should, like, everything should be set in there. So maybe we need to check our work there. Let's check this max ticks. So right here, we've got a 33-bit integer apparently. Okay, so let's just count. So we've got 4, 8, or rather, so that's 1. Well, let's count these. 4, 8, 12, 16, 20, 24, 32, 40. What? 4, 8, 12, 16, 20, 24, 28, 32. Yeah, great. Okay. So really, it's like that. Okay. Is that right? Yeah. And the value, yeah, encoded, we want it to be, yeah, those bits toggled and all of those bits toggled. So that's 6 bits toggled, which is what we've got here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, and then everything toggled in the next ones. So that means that me check. Maybe I'm not getting this. Maybe I'm not doing that right. Let's do that. And then we'll print out the value of all of ticks. Okay, that looks about right to me. One, two, three, four, five, six, seven, 8. Yeah, 33, okay. Let's check that we're getting the right slice. So we've got, so 3 bytes out of there is going to be, well, actually, let's print this out just as, let's print out the byte. Let's just print it out as decimal or something. Let's do that just to make sure. Yeah. Okay, so we've got 1, 2, 3. Yeah. So when we re-slice, let's just look at it again. Yeah, that's it. So that's our 33-bit value right there. Oh, no, it's not. See, because, no, it's not. It's not. We need a shift. We either need a shift or just account for it. Okay, here we go. Actually, first let me turn the light on. It's gone dark. I've lost in the bits. Because this isn't 33 bits. That's 40 bits. That's 40 bits. Yeah, it's so true. Yep. U30, I know. It's absolutely killing me. Five byte timestamp. Yeah. Oh, so they just store it like that. Yeah, I see. Yeah. Oh, they store it as a, yeah. Wait, so they store it big endian? Shift to 29, ORed with, I see. Yeah, these are packed. Yeah, I see. Yeah. But I guess because we're not storing it like this, we're storing it like this. Yeah. Is that right? Is that why there's such a difference? Because we're unpacking it and then packing it. But I definitely see why this is wrong now. So what we want to do is actually shift. How do we want to do that? We want to. I guess we want to do a shift initially or something. Yeah, because that, yeah, what we actually have doesn't look like this. What we have actually looks like, yeah, that's it. See, I haven't done it correctly in the first place. We've actually got it as, no, wait, on. Anyway. So the value that we want out of here isn't 1110, it's actually big endian. So it's all of that. So 1, is that going to be like, yeah, and then, so really it's just the 1 bit. No, but the single bit, that's difference backwards. So yeah, no quarter. I'm gonna have to do it 1 bit filled. Yeah, that sort of thing would help too. Yeah, I saw that there's another one like that. Yeah, where you just like put bits and yeah. Yeah, I see now the issue. Okay, so we're good. That's fine. Let's do that. Okay. So the first bit that we can actually pack is going to be only that bit there. So if I go like this, no, 30. There, see? There's our bits. So all I can get is that one there. So I pack that first, and then I pack the 2 afterwards. So that's it. That's why bytes 0 and 1 are all fucked up. That's why I've got this shit going on. Yeah, that's it. Okay, here we go. We got this. I'm feeling good. I've got it now. So this diagram isn't correct anyway. So this is it. So 0, 0, 0, 0. Oops, have I done one too many? 1, 2, 3, 4, 5, 6, 7. No. Okay. Now all I can get is 1 bit. All I've got is 1 bit, so I need to pack that into there. So that one, I need to shift that single bit from there to 1, 2, 3, 4. Yeah, I want to put it there. 5, 6, or do I want to put it there? No, just yeah, no. I want to, yeah, I've got 1 bit, I want to put it there. That's it. Like that. Now what I've actually got, oh my God, I think everything now changes, but that's cool, that's cool. Tix O is done now. So now we're going to Tix 1. Yeah, everything changes, but that's okay. No, hold up. Yeah, tix O is done. So now we want to pack from. Yeah, we haven't done this yet. So we're going to AO equal, or is that? Okay, great. Now we go B equals tix1. And we've got 2 bits left to pack here. So we've got 2 bits remaining before check bit in A O. So now we get those ones. So that's going to be OB11000. So 11 like that there. So then AO. Okay, we've got 2 bits. Those 2 bits, and we need to shift it along into here. So 1, 3, 4. So 2 bits, so it's going to be, we're going from the leftmost position all the way over to here. So that's a shift of 1, 2, 3, 4, 5, 6. And then we toggle the check bit. And then A0 is actually done. We're done with A0, so we can, all right, and then we toggle the check bit. Oh, whoops, sorry, hold up. Yeah, and then that's it. So 0, 0, 1, 1. Ooh, okay, not quite, not super happy about that. Not exactly what I was expecting, but anyway, all good. B shifted 6. Yeah, because we're getting those 2 bits and we're shifting them to that position. We're just shifting at 6. Pack remaining 5 bits from tix O, but we haven't got, no, that's not, we haven't got, tix O is done. So at this point, oh, tix O is packed all the way up here. Toggle the check bit. Okay, great. Now we've got 6 bits remaining in A1. No, 6 bits remaining in tix1. And then, yeah, and then that's it. So we're going to go like that, and then shift it 2. Maybe. Tix, oh, 1. Okay, nice, almost there. Okay, we got one more byte. Okay, so we're just not packing this correctly now. So that one there should be, what are actually getting? 0011. Okay, so that's okay. We're all good there. We're getting 0, 0, 0, 1, 1. So we're not toggling these bits, but we want to be. So it's just those 2 bits. I'm not shifting far enough along. Oh no, it's not. Yeah, that's it. This has got to be shifted left. Because if I shift right, I've just got 0. Okay, so that's it. So shift left. Okay, and we want to put this to 1. Well, I've already got that. So it's 1, 2, 3. Shift left 3. Got it. Okay, one more bit. One more fucking bit. Okay. Oh, it's cold. Okay, let's close this. Okay. Just that one bit. Okay, let's check. So 2 bits remaining. Tix O is done. That's true, yes? There's 2 bits remaining before the check bit in A0. Indeed there are. Maybe we're not doing shift correctly. 1, 2, 3, 4, 5. Yeah, it's 5. Okay, ready? Yes! Yes! Oh, fuck. Ah, we got it. Okay, there we go. Fucking hell. Okay. Oh, shit, I need a cigarette, man. Give me a cigarette. Fucking hell. It's good. Okay. Let's do some, just to be doubly sure, let's check the, now let's get, we've done that. Let's pack 0 ticks. I'm gonna have a and there's going to be an array of 5 byte. Okay, so our first test is going to be a timestamp and then max ticks, and the value that we want is going to be 5 byte, and it's going to be, we can probably, I might split this out, so let's do that, timestamp, blah, 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 blah. Max ticks, and then the array of 5 byte is going to be, so 1, and then, no, sorry, OB 1, 2, 6, and then like that. One, two, three, 1, 2, 3, 4, 5, 6, yep, and then 1, 2, 3, 4, yep. Okay, so let's do that. And then do that. Okay, now our next test is going to be the same thing, just with 0 ticks. That is actually a valid value in the, it's valid. 5 5 byte, and then we're going to have the same thing. We're going to have 0, 0. But this time in our diagram, we're only going to have those 2 bits toggled. So 1, 1, and then it's 3 zeros. 1, 2, 3, and then 1. And then that's going to be 0. And then this one is just going to be 1. So we could do it in 1, 2, 3, 4, 5, 6, 7, 1, and then 0, and then like that. Okay, now let's loop through those tests and just do the same thing. So for, let's give it a name as well. Actually, no, it's okay. We can just use the value of the ticks. Tests. The name is going to be let's do. Oh, I don't know. Oh, yeah, we'll just do sprintf. Yeah. And let's go testing T. Okay, and then now we just do all of this again. Whoops. We just right there. So it's TT dot. I'm going to call this T stamp. There's no. It's too short. It's confusing. Packed is that, yeah, and then TT dot, TT dot. Oops. Oh, yeah, okay. It's in comment in the, okay, yeah. What do you want? What do you want from me? Second thing. Fucking compiler, just let me write wrong syntax. If that for I range packed. Oh, whoops, that's all. Yeah, okay, my bad. So that's the end of the if statement, packed, test, yeah, close it off, and then we're good, okay. Oh, wow, yeah, okay. Whoa, what? What's this? Oh, yeah, no, let's get rid of that. Oh, sweet. Okay, great. Oh, man, already. It's good. Okay, we got it. We got it. We got it. It's like that Simpsons one, you know? Attach the stone of shame. I was at the stone, I was like, oh no, release it, yeah. Yeah, to the, fuck, that was good. And then that is good. That was very bloody helpful. what I'll need to do is put that into the documentation. I'm gonna get it still running. Oh yeah, but look, you know, yeah, like I think, look, anybody who knows anything knows that The Simpsons after like season 9, season 10 is just like. So I guess that was in the. I don't know what, that was a long time ago. Season 9 was 99 or something like that, 98. Okay, now that we've got those fields set, this is going to be field PTS and this is field DTS. Beautiful. Oh wow, yeah, nice. 1989 or something, 1990? Cool. Okay, so we've, oh man, I can't believe we packed the timestamp. Okay, great. So let's move this stuff up. Decode PES header, let's put that there. Let's do the encode is going to be decode, encode there, and then we've got decode and encode header, and then we've got the timestamp stuff down there because that's pretty hairy. Yeah, okay. Yeah, I wonder when it came to Australia. I know it was there was a certain, yeah. Whew, okay. Now that we've done that, when we encode, so we've got, now we can finally encode the full PES, I think. So the PES packet. So we've done, where's our struct? Okay, PES header. So we've done, we packed the fields. Oh no, sorry, that's the actual packet. Okay, length. Okay, and then now we can go if p.header does not equal nil. Then we can go, you know, is encode header and then p.header. Okay, and then check. Okay, because if not encode. We now just append the header to the buffer, I think. Yeah. Let's just check that. So header, length, and then the optional PES header. Variable length, at least 3. Yeah. Okay, great. So optional, yep. So we can put in the length. Yep. Okay, cool. So append B. And then, oh, well, now let's, when we encode the PES header, do we do the timestamp? Okay, encode PES header. If the timestamp is not nil, okay, we do some validation and then we actually pack it in. So we go pack timestamp. So now what we're doing is in the header, we are checking if the timestamp's not nil, then we know that we can hold on, PES header. Oh, the header length. And we don't store that with variable length. Yeah, okay, all right. We're gonna have to start doing that ourselves now. Okay, so length. Yeah, and then we're gonna have to track it ourselves because it's the thing. Pack the fields. That's all of those things. All of that. So our length, oh, we append, yeah, right, packed. Okay, so we append that to our buffer, we're packing it, and then we're gonna go, the length is the len of packed. And now we're gonna pack the optional, so we're gonna, yeah, encode the optional and stuffing bytes, which, you know, pretty easy because we're just storing them as yeah. So damn, now I'm just not sure quite how to do this because yeah, no, okay, I think that's okay because we store anything else that we don't know how to decode, we store that in optional. So I think here we can just go, then we can just append it. So and then again, track the length, len of h.optional. And then again for stuffing, let's just check on the number of stuffing bytes. Oh, okay, cool. All right, well, yeah, let's just do that. So if stuffing is greater than 0, then we can go, oh no, actually we can just do a loop. Okay, so we go for, starts from 0, I less than equal to stuffing I plus plus. Is that what we're going to do? Yeah. And we know that the value of the stuffing bytes has to be OXFF. And then we'll just do length plus plus as well. Okay. Oh no, this isn't right. This isn't right. No, this isn't right. We need to, yeah, no, this isn't right. We need to get the bytes. We can't append. Yeah, okay. So we need to calculate the length. So first we need to put everything into another buffer, calculate the length of that, encode the length, and then finally append these stuff. So this isn't quite right. Let's do... Yeah, we're going to need to do another... I'm going to do that. So we're going to append it like that, equals width of optional, and then we don't need to care about the length anymore. So then the opt goes into opt, and then again we don't care, and then we again append that to, yeah, I mean we'll, or yeah, we'll do that. Okay, and then so we keep adding it. Okay, and then finally we go, now we can, into our actual buffer, we append the length. So binary, so, oh no, we can actually just do the length. It's just a single byte, I think. Is that right? Yeah, so length is just a single byte, so we're going to go so really we can just do the, so buff equals append buff, optional, and then like that. And then we return nil. Okay, cool. Now what are we doing here? Okay, the header. So we've encoded the header and then data. Okay, so if p dot, okay, yeah, that's the last thing we do. Okay, p dot data does not equal nil, then we write that onto the end. Okay, dereference, yeah, sure. Stuffing. That's fine. Okay. Wow, okay, apparently that worked first go, but again, let's just check, okay. So we encode the PES header, encode, oh yeah, okay, we're not doing encode PES anywhere. Okay, let's call encode PES from our exported encode function, which is somewhere around here. Oh no, it'll be up in there. Decode, encode. Okay, cool. So when do we actually put it in? So we've done the adaptation field, and then we need to do the payload. So what we can do is, since the pes packet is actually part of the payload, we need to, I guess, do it like, you know, before we put in the payload, or I mean at the same time. So we can go if our packet if that is not nil, then put it in. So we just do it again. This is encode pes packet. And then, yeah, I guess that's it. Now, I don't know if we want this to be if or else if. I think for now, we'll just leave it like that and see what happens. Encode pes packet. That's not a pes, definitely not. Oh, what's this then? Encode error. Oh, yeah. All right, there we go. Okay, 188. Is that encoded back like 370? Okay, that's fine. I think that's here because we are else if. Okay, almost. All right, that's okay. That's okay. That'll be about how we're handling payload versus all the other stuff. So we're probably we're encoding things probably twice. So I guess it's just gonna be the boring bit of you know, going in and. So it'll start from decoding it, I guess. Yeah, here it is, yeah. Okay, that's pretty easy to see straight away, right? So what we do is that we say, well, we read the what we should do is if we parse the adaptation field, then instead of setting that as the payload, we need to reslice. So this needs to be if there's so OX01, fuck, what is that again? That means no adaptation. That means there's only payload. That means there's only adaptation field, and that means there's both payload and adaptation. So I think what we want to do here is actually, so that's okay. So what we're going to do is like that, buff equals that. Parse adaptation field. Once we've parsed it, we need to again reslice. And is this correct? We haven't put the length in there. Yeah, there's going to be a whole bunch of reslicing needed here. So let's just start like this. So this is... Oh, this means there's only adaptation field. So actually... that means payload is nil. So we don't... there actually doesn't need to be anything there. Here we need to reslice because we're still processing the payload. So we could almost call it like, I mean, really we should have like a local variable that's called payload or something like that. But, and that's pretty cheap because in Go, you know, if you just, you know, if you allocate a new slice, like it's just a pointer, I'm pretty sure. Like it doesn't actually copy the value of the bytes around. So yeah. But yeah. So we've read the adaptation field and then we reslice. That means there's no payload, so we move on anyway. Not so sure about the the stuffing bytes. That's the only other thing. Okay, fuck. Look, for now we're gonna have to put this here. And we're gonna need this length as well. Four plus one plus annotation field length. Yeah. This needs to be tidied up. Onwards. We've pretty much got the same code here, except, yeah, tricky. So we've decoded payload, and here we've, that means there's only payload, okay? So yeah, really it's here. So this really needs to read from buff. Then we decode it from the buffer. Then I'm not sure how do we know what's left, right? Because we've decoded the pairs. Maybe that means that payload is actually nil, which may actually be the case because there's stuffing bytes in the pairs packet. So for example, like if we go to pairs packet, now this has a whole bunch of stuff in it, and like there can't be two payloads in a transport stream packet. So that means that if we've got a, if this is, if we've decoded a PES packet, then we know that, I think, and let's test, but we know that there's no more payload left. So that means we can do this. So I feel like here we could actually almost have another function that's like unmarshal payload, and it'll just try and it'll, you know, something like that. I just feel like doing that, because that's really what we're doing. We're saying like we want to unmarshal the payload into the packet, you know, into our packet structure. So why don't we do that? Why don't we have a, yeah, I kind of like the feel of that. Yeah. Might. Let's go that. Let's add that function. So encode. It doesn't have to be exported. Pass adaptation field, pass PCR. Let's do it down here. So we're going to do unmarshal payload into our packet, and then that's going to return an error. And then we're going to have basically this. Now there's not a lot there now, but they're probably so unmarshal into that from this payload. Something like that, yeah. So payload just contains anything else that we don't know how to decode. So let's put that in the docs there. So okay. Raw bytes of any payload we do not know how to, or that we do not support decoding. Okay, that's fair. Unmarshal payload. So we've got our P. And our payload is just from buffer. No, and then okay, it's a bit clearer. Okay, cool. Now we can sort of focus on this bit again, because I think that's pretty sound. Okay. Is that how it usually looks like? JSON.unMarshall. Oh, into V. What? That looks decodes the bus and stores a result into the value pointed to by V. Wow, that just looks weird to me. Usually it's the other way around. But okay, look, I'll do it like that way for consistency. Now let's okay, decode. All right, buff. Now that we don't want to do. That just needs to be this needs to be like this. So we don't really, yeah. Let's do that there, and let's get rid of that. Whoa, no, hold up. Let's do it the other way around. Okay, so the OXO2, OXO3, like this. A bit of thought went into that. Okay, cool. That was better. Okay, now we're gonna encode packet 4, about encoded packet length 194. All right, that's cool. All right, let's look into, let's just sort of think about whether we're encoding this correctly. So we're gonna get the adaptation field and we reslice. So we say, okay, we've read all of that stuff. Cool. So, yep. And then we unmarshal the payload. Cool. All right, seems all right. Let's look at encoding. Okay, adaptation, fine, yeah. Very 188 was 6 bytes over, by the way. So, yeah. Okay, payload. Code PES packet. All right, next up. Wait, oh, it's in PES. My bad. 6, yeah. P data does not equal nil. Pen data, okay, seems fair enough. So maybe we're not encoding the PES header. Doing something wrong there maybe. Why don't we do like a little, oh, actually, no, okay. Let's finish going through this thing. And then, yeah, just a quick like sort of read. So that's 6 and 5, 4, 3, 2, 1, okay, whatever. Yeah, okay, here we go. This is looking... h.timestamp. We know that that's a correct length, that's 5 bytes. Or is it? Yeah, it has to be 5 bytes, but... Hold up. Oh yeah, no, it is. Yeah, no, it definitely is a fixed size of 5 bytes. Yeah, 100%. Because the wire format is looking like this thing. So that has to be 5 bytes. It's set. Okay, so that's fine. Okay, cool. So we're good there. So encode PES header. All right. So we do the timestamp. Optionals not equal nil. So maybe we're getting something. Where do we get optional from? So when we decode the PES header, are we... Oh no, that's right. Yeah, okay. Yep, so we get that, and then we set optional. Fucking hell. So we're re-slicing there because we've read the timestamp. Everything else we store into optional. Okay. So that's how we decode it, and then when we encode it again, yeah, no, that's right. Yeah, and then we pack it up, append it to this sort of little optional buffer we've got here, and then we, yeah. Ah, the stuffing. We're not storing that. But we can get that. We can get that later. I mean, we're going over, so we're definitely not appending. It's definitely not an issue with appending the bytes, I mean. Let's find the bits where we're actually appending stuff. Well, actually, first up, let me think. Hold on. Okay, we know it's packet 4. So let's go and let's open up Wireshark and see what is in packet 4. Now that we're sort of a little bit lost. Okay, 4. There's no payload. What? There's no payload after all that. Okay. Oh, no, there may be, yeah. Where's that adaptation field control? Header there. Yeah, there is payload. Okay, that's fine. So there's our adaptation field, and then it's just 7 bytes. And then we've got payload, all of that. So everything from there. So that 00 onwards is the payload. All right. So we go to adaptation. Let's track the length as we go. So we get to after is that. Okay, there we go. All right, so 12. Before encoding PES is 12, so that means 4, 8. Yeah, I think we're 1 off on the. Adaptation field length is 7. Yep, 7 bytes. Plus 1 is 8. Yep, which makes sense. So we've got the 4 byte. Okay, so that's all good, yeah. So some of the way that we're encoding this PES, that's wrong. We're getting too many bytes. We are 6 over. We should just be getting 188 there. Start with 3. Oh. Yeah, hold up. We're doing 3 here, but we're only using 2. Why is that? Ah, this. Okay, look, the length there, like that. So that first, since we're starting with 3. And then still weird though. I don't know why. Hey, what the fuck? Buff 2. Huh. That's so weird. The length is still the same. Maybe it doesn't. Okay. Let's track maybe a timestamp. Yeah, definitely something here with this optional on the timestamp. So if we read the timestamp, we're sure where he's slicing, yeah. Decode, okay, so we're doing that, and then we're saying, yep. We're reading the timestamp from, yep, from all the way there, so. Zero, 1, 2. So that's all of 3 used up, so that's good. Presentation timestamp, blah, blah, blah. Packed equals packed timestamp, it's 5 bytes. This we know that's 5 bytes because that's the value that the compiler will tell us otherwise. It's just a value. So append. Why don't we do man, this is hard. Computers are hard, man. It's got to be in here somewhere. Okay, so the PES header only has the presentation timestamp and decode timestamp. It's got two of the motherfuckers in there. Huh? Oh, this is probably the bit that I got confused by. So when that is set, so if the PTS and DTS flag is set, that means there's two timestamps in there. Okay, that's why I was getting confused. All right, so there we go. All right, that's why. So our timestamp struct is all wrong as well then. That's fine. That's easy enough to fix actually, because we're just having we'll have two fields in our packet, PES, PES packet. In the header, there's actually going to be two timestamps. It's going to be presentation timestamp and decoder timestamp. That's all. Let's do that. We can actually just call it presentation and decode. I don't know. It seems, we don't need to do that. Okay. Knock that out. That's fine with the compiler. Yeah, thank you very much. Okay. So this is it. So if we have the PTS, then we're going to read in a just set the things, okay, and then read. Okay, cool. And now we're just going to do it again. If h.fields field DTS, and just exactly the same thing. Let's probably put it into a function, but anyway. So this is presentation, and this is h.decode. Okay. Okay, so again, same deal. Presentation is not equal to null, then pack the presentation. Okay, and then the same thing. If h.decode, so now we again, if h.presentation DTS, yeah, blah, blah, blah. We can actually just check this once. Oh no, actually, no, we have to check it again. Okay. Oh, it's still 194. Okay, well that's okay. That's okay though. I mean, like that's actually pretty good. Like that means that our logic is sound for all this. (194 minus 12 is 182. What about the, I'm missing something. The data? Oh, maybe we're setting the data incorrectly. Hold on, data. Set data. There we go. That's it. Okay, so what's happening is that there it is, exactly there. There's our 6, right? So what happens is that we decode the PES header, and then we're just saying, oh, okay, and then we just throw everything into data. But no, that's not what we want to do. We actually, that's not correct. I think here we can just go, we've read the header from 6 onwards. That means that well, actually now, I mean, this we've stored. We've stored everything up to this. So now we can just reslice from there. And then we can just do like that. And then Yeah. Okay, there we go. We're good. Yeah, almost there, almost there. So now we've decoded the header. We want a kind of way to like work out how long, like maybe how many bytes we read or something like that. Maybe there's a thing, maybe there's a rule somewhere where we can kind of take a bit of a shortcut. We can say, well, this is the PES, so we're in the wrong file here. So if we have the header, then maybe we don't have data or something like that. That would be great, but I'm not sure that that's the case. Fuck, okay, now we're actually getting into the MPEG-2 video thing. But we don't need to do that. We could probably get the length out of here. So one thing we could do, we could return a byte count of how many bytes we actually read out of there. Maybe there's a marker or something like that, which there's not though, but we could, just surprised there isn't a length or something. Oh yeah, there is. There's the header length, right? So the header, optional PES header has a length, right? Yeah, there we go. Okay, so, and we store that, do we? The remainder of the PES header in bytes. Yeah, great. And then we can just, okay, sweet. Okay. Let's see if we keep that somewhere. So the PES header. What we're going to do is we're actually going to store that. But we don't need to export it because it's only for our sort of interest. So this is number header length, the number of bytes from the header up to data. To beginning of data. Okay. And this is just going to be let's just do it in, doesn't matter what it is. Actually, it is a unit 8, so. Okay, so when we decode it, we need to get that length. And we decode. That's that H length, here we go. Okay, so let's put this here. Well, actually, you know, we could almost put it in the header itself. Can we put it there? Oh, the remainder of the PES header in bytes. Motherfucker. Okay, yeah, no, we almost got it because we know that that's, so all of this is a fixed length. So it's really going to be okay. this is, okay, no, I'm gonna put it here. It's just gonna be length. Number of bytes. No, but we can just calculate it on the fly because we know the size of all this stuff. That's 1, 2, and those are 5. That's 5, and that's just the length. So we don't need this. You can reslice here. So the header length here is actually, we can work it out. So we're just going to calculate it. So it's going to be, so header length equals 1 plus 4, 5, 6, 7, 8. 2, that's 3, so it's always 3. So this is the flags plus fields plus optional, like the option plus field length is really what that is. So then that means that here the so the number of bytes read is going to be header length plus some other stuff based on what we've got here. So this is going to be, if we've got a timestamp, okay, so that's, so that's it. So we're going to do timestamp, check if the timestamps are nil, and then length of optional plus, well, that's it, plus length of optional. Might even need a little function here. So this is the packed length. So this is the packed timestamps, 5 byte. Just do that again, just to be very sure. Okay, there, and then we do that, and then finally, we can go we can just reslice like this. Buff equals buff from the packed length. Pairs.header.packed length onwards. I think we might be off by 1 there, but let's just see. Yeah, off by 1, okay. And then we're gonna do that. Is that -1? Yeah. Oh, +1. Or not? Oh, -1, okay. That should be the length. -1. Yeah, it was -1. Packet 4 encoded and source bytes differ. That might be a source of the bug that we're getting here. Okay, so packet 4. In packet 4, byte 3 is different. Let's have a look. So packet 4, byte 3 then is going to be 2, 3. Continuity counter. What? It's pretty weird. Sync byte. Oh, no, that's just that's single byte. Oh, yeah, sorry, okay, on 1. Yeah, no, my bad. So it's 0 to 3, so 0, 1. Continuity counter there. Packet 4. Encoded and source bytes differ. That's our encoded. Well, do we have a oh no, yeah, we can't. No, okay, so it's just, oh, shit. OX0102. X0102, 0102. Okay, so packet ID is the same. Oh, it's before that. It's the fuck is it? So continuity? It's not continuity, it's before that. Zero, one, two, three. Oh no, it's after that. It's scramble, control, adaptation for control, or the continuity counter. Let's print this out a bit more. Print it out as like hex or something. Decimal doesn't really mean anything. Or even binary. There we go. Okay, so it's really just one bit. Okay, so in byte 3, so we go along here. So that's 0, 1, 0, 1, 2, 3, 30. So 0, 0, 1, 1. So what's that? 0, 0. Adaptation field control. So we're not setting something right there, I think, because we go 8, 9, 10, 11. So 8, so 1, 2, 3, 5, 8, yep. So first 2 bits are transfer scrambling, it's this adaptation field control. Okay, we're not toggling that correctly. So let's toggle it. Let's toggle it good. So go up to adaptation field controls in the packet. Yeah, it's just weird. I just don't understand how we're not. Anyway. 0. What is that? Ah, the payload. We're not toggling that bit. We need to look in, and so when we, that's it. So we need a payload. There we go. Here, this is it. So it actually, it isn't this. It's we don't just want to check if the payload's nil. We need to check if the packet is nil, because we're actually decoding part of the payload now. So when we read the packet, yeah, because we've read all the payload, so that means that it is going to be nil. So that means that, yeah, we're not toggling that bit correctly. So we need to check also if that's not nil. That means, you know, we need to say, hey, like there is payload, but so it's this, or p.pes packet does not equal nil. That's all it is. Packet is no method. Pes packet. Not fucking ass. Oh, pes. Okay. Cool. Nice. Okay. Got it. Okay, we're just off by one somewhere here. So packet 10. Packet 10. About encoded packet length. So what do we got? We've got packet 10 has a adaptation field and payload. It's this shit again. So it's something, probably something to do with that length being 1 and whatever. So what if we encode the packet? Let's log the packet as well. Oh. Payload's nil. Pes is set. Yeah, okay, there we go. 257 scrambling 0 adaptation set. Okay. So we could try and let's look and actually go through and fix that. 189. Okay, so one way we could check this is actually go and see where we're getting that extra 1 from. Although I do feel that packet length thing is a bit tricky. No, it's pairs. It's got to be -1 there. Where's a +1? I'm so confused by this. Like if, yeah, no, exactly. Yeah, it can't possibly be that. It's got to be -1 because, like, The index, yeah, it's start from 0. The length is from 1 to 0, yeah, so that's it. As we're 2 bytes off, which is fine. So if we go, how could we check this? So in Wireshark, we could actually see the length of the adaptation field and stuff like that and see if we're getting what, yeah, let's do that. So let's go here and let's print out what we actually got. Print out the contents of the packet. So we've got a packet here. Let's do this log f. P if p dot adaptation log that as well. And then if p dot pes, no, let's also log that. Okay. Oh, whoops. No, okay. We want to, yeah, no, hold up. We don't want to do it for every single one. We just want to do it for the one that we failed to encode. Let's do that here. Yep. Sweet. Huh. What? Ah, yeah, there we go. Okay, cool. Need to log something a bit more verbose because I can't remember what any of those fields are. Okay. So the adaptation field is that. And then the pes is that. So let's see what that looks like in Wireshark. So adaptation field. Yep, just a discontinuous. Yep. Okay, cool. Oh, we're gonna have to go all the way down to packet 161 to find out. Okay, here's our pes. Audio, okay. Header, here we go. Just has a presentation timestamp, okay. Oh, there's extension as well. Alright, we'll look at that later. Audio stream. Oh man, this is a real bitch. Pes. That's this thing here. All right, so the length is 5720 and the ID is 192. Oh, exit, yep. Okay. The header, all right, so we need to go in there, okay? If pes is not equal, no, okay, and then again, if p.pes dot header not equal null, then we log that as well. Pes header. Scrambling 32. Priority false. It's just optional. That's the only place where we can be out. Because there's, yeah, because that's a variable size. Everything else is constant, so I don't think, so it's got to be in there somewhere. So when we encode pes header, and we decode it okay? Yeah, we do. Oh, all right. Timestamp. It's got to be this optional. Two bytes apparently. That's weird, 2 bytes. Maybe let's see where that's called from, encode pes header. Let's go there. Okay, so data has a single byte in it, which is interesting. Let's check if this is right. I've got our numbers right here. 4, 5, 6, okay. 6, yeah. Put that in. All right, and we got stuffing is 0, okay, fine. Maybe data shouldn't be. There we go, appending 1 byte from data. Almost there, okay. let's see how data gets filled out from when we decode it in the first place. So we're going to do when we decode the PES header, which is just here. Oh, the PES packet, sorry. So decode PES packet. All right, there we go. Interesting, huh? Let me think about this for a sec. If we get the PES header, 3, 4, encode PES header. I got my eyes too bright. Optional PES header. Okay, let's read this again. Let's make sure we're not off. 4, 5, 6, 7, 8. That's 1. 2, 3, 4, 5, 6, 7, 8. It's 2, 3. Plus the length. So let's look at this packed length again. The header length is 3, yeah. Yeah, it's 3, and then we go plus 5 plus equal 5. Yeah, and then we get the optional, and we're good. Okay. Optional. I'm interested because that byte there is the same as that byte there. Anyway, let's go and get this pack length thing. So the number we read is going to be 3 plus 5 for each timestamp. And then the length of the optional field. And then stuffing, but we're kind of using stuffing in the optional bit anyway. Okay, PES header length 8. Yes, that's fine. these variable length things that are the bitch. Stuffing? Oh, hold up, hold up. There we go. Okay, almost done, almost done. Okay, that's 1 byte because we're not dealing with, so we're going to do okay, that's 1. That's 1. Okay, we got 1 byte to go. We've got a double off by 1. We've got rid of 1. Now we just got to find the other one. What if it's that? I just don't get that. Oh, let's get this right. Oh, you fucker. Oh no, there's a lot. Oh. No, okay, there's a lot there. I'm not convinced of that. I'm still. Yeah. Okay. Let's see. That data thing, that just looks weird to me. Where are the other variable length? Where's the other variable length stuff? It's got to be in got the header here. All of those are nil. So this is the actual, no, sorry, this is the packet. Does the adaptation field even have any variable length fields? Because I don't think it does. Oh fuck yeah, it does too. There could be an off by 1 in there somewhere. Let's have a look at that. And PCR, that's set. Okay, so raw bytes of any, yeah, the extension. Because I know that there's a lot of extension, like there's a lot of stuff set in there. So let's have a look. Let's go back to our adaptation code. So we'll close that for now, and then we'll just adaptation.extension. Yeah, here we go. This is interesting. Looks like this. What's that I again? That's the telling us how far along. Yeah, the cursor. Oh, the length of the private field. Yeah, okay, so. Oh no, sorry. Yeah, no, but that's the extension. It's just nil, so it's not that. I mean, it's like it's 0 length. Splice countdown. Should that be? extension prefix. Let's go back to packet 10. Okay, adaptation field. So all it's got is discontinuity. Correct. There's no splice countdown. Correct. So 0 doesn't mean anything, and then everything else is empty, so that's fine. Okay, so next on, we go to the five times 20. Yeah, okay. Maybe we could look at these or something. Let's look at that. We could actually get the hex out of that or something. But in here is, does it tell me which byte I'm on if I click that? No, it doesn't, does it? Oh, so annoying. There's bits. Hex. Can't I show as text based on as ASCII? Oh yeah. 00010. Well, what are my indexes? Oh yeah, okay. Yeah, got it. Okay. So we go 0. So we do the adaptation is it's that. Field extension flag. Ah, yeah, no, that's it. Okay, continuity. Okay, so then adaptation field. Yeah, it's just all that shit. And then after that, in our packet is pairs. Okay. ID. Well, 92. Yep. Or not. Zero, 0. One of the things I could do is actually like encode, when I encode the packet, instead of I could actually do this, right? I could go if, yeah, I could actually just go w.write and then if n, right? And then done the same thing. Well, actually, I could be very naughty and do that for now, and then let's just go back, and then that, and then that. Maybe we'll do that. Or even Yeah, I could just print the hex out. Okay. All right, here we go. So let's get that here. It's that there. And on the way. There we go. This is going to be dirty. Four seven four one. Is it? Oh fuck. 0 0 3 0 0 1 8 0 0 0 0 0 0 1 C 0 1 6 5 8. There we go. There's it. There it is. See it already. C0 C0. There. That's it. It's that 1 byte from data. So we're off by 1 somewhere there. That's it. So that there. Okay. So appending 1 byte from data. Where's that data field again? That's in the pairs. So data. So decode, let's have a look. Decode pairs. Is it this then? Can't be. Oh shit. Yeah, no, it actually might be that. Because there's barely any... Oh yeah. Okay. Let's try that anyway. Let's try. Because I think then it goes through the whole... Yeah, okay. So it is that. Okay, fine. All right. So we got... All right. Yeah, let's go through. So byte 12. So packet 10, so encoding and source bytes differ. Let's get rid of the packet length. Okay, packet 10, all right, let's get this. Byte 12. So byte 12 of our encoded packet is not right. Let's have a look. So byte, so here, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sorry, 0, 1, 2. know that's 8. No, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that one. Okay, there we go. And in this case, it's byte 12. So what have we got here? We've got a packet 10, which has, wherever packet 10 is there. Okay, so it's just in the payload, so that means it's in the PES header. Byte 12. Thirty-three 055. Damn, it's hard. Let's put that down. 10, 11, 12. Always the same bytes. So always at the same byte index. And always, there we go, look, and always the same thing. So let's have a look at that. In the PES header, oh yeah, here. And then, so, field 0. Yeah, that's it, the fields there. That's it. Let's have a look. So, I mean, before I go there, let's go, yeah, here we go, byte 12, 13, 14. Okay, so let's go, oh yeah, look, it's yeah, it's all the same stuff. Looks like we're just not setting some flags correctly. Yeah. Okay, so let's look at packet 10 in Wireshark. And then go to the reassembled one so we can see the PES header. Here we go. All right, so that's our binary there. So it's going to be 1, so we're looking for that value there. And I have a feeling it's got to be in the header. So it's 1, 0, 1, 2, 3, 1, 2, 3, 4, 4 zeros. Yep, and then 1. And then data alignment. Now, when we encode it, it's not. It's actually, we get something quite different. We've set some totally different flag. scramble control. So apparently when we encode scrambling, we're not doing it correctly. So let's go into pairs, scrambling, there we go, okay. X30. Let's do this, maybe 0, 0, 1, 1, 2, 3, 4. Yeah. Yeah. Okay. Okay. 1, 0, 1. What the fuck? How do we possibly get that? Scrambling, decode pairs header. Three, 4, 5, 6, 7. That's really bizarre because, yeah. Hmm. 4 to 5? Are we doing that incorrectly? We've got 4. It's only 1 byte then. Yeah, exactly. Let's look at those other bytes. Byte 10. One, 0, 1. What if I do like something totally wacky here? Like let me do yeah, there we go. Okay. It's like I'm not storing that correctly. Just straight up not storing it correctly. And then also I'm not even 7, 6, 5, 4, 3, 2, 1. 7, 6, 5, 4, 3, 2. I think I'm off. I'm off by 1 here. 2, 3, 4, 6, 7. And that should just be 1. So this is incorrect. This is 1. That's 1, 2, 3. That isn't 7. Ah, that's it. Yeah. Oh wait, no. Oh yeah. No. That should be. Yeah. Yeah. Okay. Let's try that. Huh? Oh yeah, we got it. Okay, great. So that's that byte done. Because byte. Oh no. Can that be 1, 0? I'm just toggling the bits. Scrambling. One, 0. Yep. Then 0, 0. But when I read it, I'm like not reading it correctly. Decode PES header. Zero. Oh, here we go. There it is. There it is. The length is, that looks wrong to me. Oh no, yeah, that's right. Length. Yeah, that's it. I missed. Yeah. Yeah, they're the fields. No, I've missed it. I've sliced too soon. Premature slice. The premature slice. So what it is here is the field. Yeah. This is it. So we've got the marker bits, right? And then, well, not only the marker bits, but all that other shit. So those are our flags. So they're in the 0. So there, that's that. First up. And then the next one are what we call the fields. So the fields are and really we want like this up here. Like that. And then that's it. H length, and then do we use that? Okay. And then we've already done that. 0, 1, 2. And then we just do a length check just to make sure everything's okay, and then I think that should be it. Oof. Okay. Flags. Yeah, so 0, 1, 2, and then we, yeah, and then we're good to rock and roll, I think. So when do we next use buffer? All the way down there. Well, we've read the bytes, so we can, yeah. Okay. So now we're in deep shit. Oh yeah, it is. Yeah, it is absolutely, yeah. So and then now (14, 12, 13, 15, 16, 17, 12, 13, 14, 15, 17, 12, 13, 14, 15, 16, 17, 12, 13, 14. Yeah, okay, cool. And then I've got another sort of, I've got another alignment problem. So that's fine. So that's all good. The scrambling is good. I feel like the length is okay. Lengths are all right. Let's deal with packet 10 again. So we started at packet 10 and we were at byte like 12 or 13 or something. So that's where we are here. So it looks like the timestamp packing is not good or something, maybe. Or decoding. To 101. What? Ooh. Quite different. Quite different. By 12. Pretty sure that's a timestamp. So let's go and let's go to read the timestamp. And then maybe for shits and giggles, let's just return because I mean I'm assuming that packet 10 is the first one that has a presentation timestamp in it. It's not. PES header data. PES data is something 12. Although it is the only one with just a PTS in it. So let's do this again. So we've got 4, 0, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Header. Byte 14. Okay, another way to do this is let's get a single packet that we know, because here we can sort of like manually build up the packet ourselves. So we can just do test on one single packet, because I think we're at that point where like, we need to like check the actual values that mean something to us. So let's have a look. If you have this thing in func, actually, let's do this. Okay, so let's have a go at doing it like this. Let's quit that. Let's move this over here. All right, now we can go and build it up ourselves. Okay. So error is false, whatever. Okay, payload unit start indicator. So payload start is true. PID is 011. Okay, that's it. Adaptation is just discontinuity, I think. Yep, cool. Okay, discontinuity. Okay, we have a PES packet in here, which we can look at over here. Okay, the stream, the ID is a OXCO. And can't remember what else is in a PES packet. ID, length. It's a big number. 5720. header. Yep. Okay, let's go in there, the header. Where are you? Here we go, scrambling. Okay, so now we can just go through. So scrambling is 0, blah, blah, blah. Alignment is true. MPEG-TS flag. Copyrighted original, so not copyright, not original. PCS flag is true. These are our fields. Okay, so fields is just that, I think, which is really just a value of field PTS. There. And then yeah, let's just check our constants just to make sure. Field PTS, yeah, that's it. Okay, cool. All right, so we've got fields. Okay, we've done our fields. Let's just see what's next. Pairs header. Scrambling priority. The timestamp. Okay, so we've definitely got a presentation timestamp. No, that's true. And the ticks. Okay. Ugh. Is 10.0, so that many seconds. So maybe we can get that as a decode timestamp is still optional. Okay, that might also have a bunch of stuff in it as well, but maybe not. Ticks, other length, optional. Oh, okay, no, that's it. Okay, and then apparently, what do we got after that? Any data after that? Lots of data, but we can go back to packet 10 and just double check, because these are the actual, that's all 188 bytes there. So let's find our timestamp in there. So it's 0x2100 2100 377E5B FF F1 blah 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 blah. So heaps of shit after that. So I guess that'll all be in the not in optional, because we know that, well, unless there's 1 byte of stuffing in there, which could be. But that'll actually be the, in the actual data, it'll be a whole bunch of stuff in the PES packet. So when we've got our packet, after the header, we've actually got a bunch of stuff, and then this is going to be very big thing. And then could we actually calculate how long it is? Because we know 5b, that's the end of the ticks. FF. Oh yeah, we can work it out because that's 7. Zero, well, 8, 16. Right, 1, 2, 3, 4, 5, 6, 7, 8. 16, 17, 18, 19, 20. So this is, let's just do, let's leave it as nil because it's okay. I don't really. Okay, now when we decode, is that what we want to check? Oh no, we encode it also. So. There we go. It's what the packet bytes, that's what I want. And then I'm just going to save that to so now if I should be 188. Nice. Okay, there's our byte. So there's our packet. So what we can do is let's grab that here and then move it into okay. Okay, now we're just going to do this really boring diff. I can actually go down into it already because I know that it's going to be in the header. Adaptation word. Pes header. Adaptation. I'll just continue this. Oh, there we go. And then let's only run this one function. Okay, here we go. There we go. All right, so first off, we're not decoding the ticks correctly. That's the first thing. So let's fix that. Yeah, I can already see it, right? Like we're off by a lot here because we want to, the zero, it needs to start at, yeah, no, that's not it. So the array, yeah, okay. Oh, yeah. Hey, how's it going? So here is we only want to start at byte yeah, it's we need to start at well, we need to end at 8. Sorry, we need to end at 7. So it's like going to be like that. And I think, no? Anyway, let's just give this a go and see what, because I'm getting pretty tired, so brain's getting fried here. 5, 4, 4, 3, 3. Or not. So that's the stuff that we've read in. So we're gonna first 1, 2, 3, 4. get this diagram out again. Okay, so the first byte that we're gonna store is well, the first few bits is going to be, I feel like I just want to do this. I really only want, I've got this really wrong actually. I've got this super wrong. Yeah, I've got this really wrong, I think. Yeah, definitely not, because the bytes, yeah, no, I've actually got it backwards. So let's do this properly. So we're gonna start with 5 bytes, enough for 33-bit integer. Okay, let's do this all over again. So starting at 0, obviously. So we've got these bits. So our first byte in this particular slice is going to be, we kind of want it to, well, it's going to look like this. It's going to be 0, 1, 2, 3, 4. It's going to be, this is actually going to be a whole bunch of zeros there. And then we're going to be 1, 2, right? So there, yeah, like this. Like that. That's actually what we want it to look like, which we're definitely not doing here. So let's try again. What I'll do is I'll just comment all this out, and then, because that's still, yeah, that's fine. Okay. Okay, so all we want is this 1 bit. And then that is going to be shifted 1, 2, 3 positions. There. Move on to the next byte. Okay, so, or the next like couple of bits or whatever. Now I think we can just start toggling bits. Yeah, for this one we can just toggle bits, I think. No. Oh, anyway, let's just see how we go. Okay, so tip off 1. So now we've done that. Okay, let's go. So we got with those 2 bits. So that's maybe 2, 3, 4, 5, 1, 1, 1. Yeah, that's it. And then all of that shit is going to be shifted to the, 1, 2, 3, 4, 5. Okay, and then that is That's A0 done. So we move on to the next. A1. We've done those. All right, we've done 3 bits. So we've done them. So now we've got so we've packed that one, or we've unpacked, yeah, because we're unpacking this fucking thing. So we're unpacking, so we've unpacked one. Yep. We've unpacked that. So now let's unpack that into there, that into that, so that we've got 6 bits left, so we can get 6 bits out of it. Yeah, okay. Like that. And then we get 1, 2, 3, 4, 5, 6. So we need to shift it 2, I think. Because we've filled out, yeah, we've already unpacked these those 2 bits into here. So we've got to fill up those ones. So that's that shifted 2, yeah. Okay. That's tbuff1 done. Okay, let's get the rest out of there, because we read we read 6 out of A1, so we're getting those ones. And now where do we put them? Well, that's easy. We can just do that because, yeah, we haven't done anything yet. We can do that because this thing, we haven't touched it yet, so that's empty. So we can just put them there, okay? And then we've done A1. So now we go on to A2. And we've got 6 bits left, so we can just grab those ones. And we need to do 2. So yeah, I feel like we can do that little hat operator. I'm actually not super familiar with that. See you, mate. Okay, sweet. Now we can go on to okay, so we're reading this, so we're unpacking the timestamp. So we got, I want to call this unpack. So A2. All we can do now, okay, we filled up this one. So now we can fill up the next one, I think. Because we've read Yeah, because we've unpacked it into tbuff2, which is this thing. Yeah, so we're full up now, so we need to move on to the next one. And where are we up to in A2? We've just got 1 bit left. Okay. And that's going to be shifted. Yeah, because we're fresh. So again, we're doing 6 along. Okay. A3 is done, so we're going to A4. And we want now, we want 7 bits, next 7 bits. And that's shifted just 1 along, I think. Whoa, no, so that's A2, and this is A3. Oh man, this is crazy stuff. I'm gonna, yeah. So we've read from tbuff3. No, we've unpacked into tbuff3, which is this thing. So let's just double check. So we've got A3, 1, 2, 3, 4, 5, 6, 7. We read that bit. So we unpacked that bit to here. 1, 2, 3, 4, 5, 6. Yep, that's right. Okay, now we're going to go A3, OB1, 1, 1, 1. So A3 is this. We've done that one. We could actually do this like actually just update this as we go or something like that. We'll go like, let's do this like as a, I don't know, like a dash or a pipe or something, I don't know. Let's do a dot, 1, 2, 3. Oh no, let's do this, 2, 3. Okay, cool. So we've read that into here. So let's get, we've got 7 bits there, and we've finished that one, so we can read it from A3. Yep, and then we shift it along 1. Yep, sweet. Okay, so we've filled up these now. So because we've done 1, 2, 3, 4, 5, 6, 7. Okay, the A3 is filled up, as we can see. Okay, we're going to fill this thing. So we've got tbuff. No. Tbuff. Yeah. Tbuff3 is also full. And A3 we are almost done with. We've just got 1 bit left there. Okay, so tbuff4 equals A3 and whatever's left. There. And that needs to be shifted all the way along 7. Because we're starting a whole new thing, yeah. Okay, and then tbuff A4 is going to be, yeah, this is it. Yeah, this is it. This is it. We've done it. Okay, now this is just the A4. So we've read A3 And so we filled that up. So all we've got left is to fill those things. So we get it from A4, and we've got everything up to the end. So we've got 1, 2, 3, 4, 5, 6, 7, 0. And then that's actually just shifted to the right once because we want to put it into there. And then we're done. Well, okay, hold up. Okay, before I got too excited. Okay, so that's our timestamp. So that means the tstamp.tix, or the, it's going to be, now we need to read it as a big endian. So tix equals binary dot big endian. Three, and then tbuff. So and then all of tbuff. So actually, what we do is we do something like, I mean, in here, these are really the ticks. So what we do is maybe do like, so our int buff is going to be a, I think, 8, and then I'm going to copy from into from 0, 1, 2. It's going to be 3 onwards. No, from 4 onwards. So because we've got 7, so we want 4, 5, 6, 7. That's 3 onwards. Like that, and this is going to be that. So we're going to read the UN64 out of that buffer, and then like that. Let's see what that looks like. Oh my fucking God. We're gonna need to is that doesn't seem right. The A0 and OBO that shifted 1, 2, 3. Yeah, no, that actually seems right. because we've got it encoded like this. This is how it's packed. That's how we actually want it to be like. Oh, no, maybe it's not. Maybe we need to do it the other way around. We need to do, if it's big endy, we need to do it the other 33-bit. No. 33-bit. Yeah, that's correct. Yeah. So it's like that. Yeah. So let's just do this as D. Let's print this out as binary. No, it's 33-bit. There we go. There we go. There we go. Oh, this isn't, hold on, we're missing something here. We want the, how do you print that out again? Hash. That isn't 33-bit. Or is it? Yeah, it must be. Oh. It's not 33 bits. It's 38. Okay, so it's storing this wrongly as well. Zero zero 377E 5B. Okay, but we know that it's actually not that. That's yeah, no. That's obviously not it, right? Ten 10.0101. I can pretty much work it out. I'm fucking getting it. I've got it. There we go. Yeah, I've got it. All right. Okay. Awesome. All right. So now all we've got is, well, I mean, basically the same error that we had, but we've got byte 14. So what is byte 14? In packet 10, so it's 7, 14 there, 21. Bytes in. Four, 6. Rotation field length is just 1. Okay, so it's 1, 2. So we got the 4 header. And then we've got 2 bytes, so it's 4, 5, 6. And then we dip into the payload. The payload we know is a PES packet. So the PES packet is decode PES packet. Oh, fuck, I forgot where we're up to. So we've got 4, 5, 6. 4, 5, 6. Yeah, okay. And then we go the PES header, or PES packet, sort of, what do they call it? The start code. Six, 10, 12, there. Optional PES header. Okay. 14. So go from 6 adaptation, and then we go to the payload, and we get that. We get 4. 3, 1 is 4. So that's 10, 11, 12, 13, 14. So it's in the first 2 bytes of the PES header. So if we encode the flags and the fields, apparently, which I'm very surprised by, but okay. Let's set this as like set it as that, and then let's see what we get here. Yep. Okay. Source is 0, 0, 0. That can't be. Can't be. The PES header starts with can't be that the PES header has got to start with 10. So that's just wrong straight away. So we're not decoding it correctly. Something. Byte 14. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 05. It's before the timestamp. Before the payload? That's in here. Stream ID, maybe I'm not. Okay, the PES header. It's there, 8005. That's where it is. Let's go back to another test like this again. Encoded OXAD. Yeah. That's it. 100%. It's right there. It's byte 14. Count again. All right, so we're going to go from the PES. There's an adaptation field. Okay, so this is 4 bytes, so that's 4. We know we've got 2 bytes there, I think. Let's confirm. 1, 2. Yep. And the rest is payload. So 4, 5, 6. 9, 10, 11, 12, 13, 14. Wow. So we're getting something really, yeah, that's bizarre. So 14, it's here. So we're not, let's go back. 6, 9, 10, 11, 12, 13, 14. But we're hold on. We're counting from 0 in this thing, so it's actually 15. We'll go back. Let's do this right. 0. So this is 4, blah, 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 blah. Okay, so it's just shifted along. So 14 is actually 15 in our counting. So it's 15. So in our case, it's actually 15 and so 13, 14. So the length is correct, I think. So it's actually that. So it's 0, so 0, 7, 8, 9, 10, 11, 12, 13, 14, that's 05. Which is what we're getting at. Yeah, I got AD. So that's once we're in the PES header, going 6, 9, 10, 9, 11, 12, 13, 14, and then, okay, so the header length apparently is wrong. PES header length. Let's have a look. Okay, so that's our first problem. So that's where that where the 5 comes from? Yep. Encode pairs header. Get our length way fucked up. Yeah, length is absolutely fucked. That one here. Is this the stuffing? No, it can't be. No, it's not the stuffing. So how could we be getting such a big difference? We're getting like, yeah, big difference. Looks AD. Length of 173. So when we're getting here, the length is 173, which is crazy. I mean, like, there's no way. Oh, that's it. There, that's it. We need to, no, this is wrong. We need to get the length. See, because we get the length here. So this isn't, so this, no, that's it. This is actually 3 plus h length. Yeah, there we go. See, fixed. because what was happening is that we were getting the optional field like super long. Because it was just everything left. But what we were actually acting on was this, yeah, like here we should really pass in a specific length or something like that, but we're not anyway. So that was really fucked up. Anyway, so we got packet 10 now, and we are gonna go byte 15, so the next byte along. So we packed our yeah, so the next one along is going to be from the presentation timestamp. So looks like, oh yeah, okay, looks like we're, okay, getting the first byte of our timestamp is, oh yeah, I see what that is. Yeah, we're not setting the PTS flag in the timestamp, so pack timestamp. Yeah, it's funny. So the PTS, we haven't decoded the presentation timestamp correctly again. Because that bit there is the, fuck. Let's get rid of that header length because we know we're good now. Yeah, that's our timestamp. So if we go to pes header, we decode the timestamp. Yep. Read timestamp, that's it. Oh no, tstamp, read timestamp. Huh? Okay, read timestamp. Field PTS greater than 0. No, that's not it again. The field PTS, I think our bit mask is wrong there. Yeah, it is. See, because in this structure it's different again. Fucking thing. It's actually this. Oh, 1, 2, 3, 4, 5. And then, so here, fuck me. And this is this. Like 1, 2, 3, 4. 1, 2, 3, 4. Yeah, like that. There we go. Fucking hell. Because the structure is that. That's the packed structure. Okay. Byte 17. Woo, okay, so which packet? Packet 10, okay. So 15 is here. We know that's 15. 16, 17. Huh. Interesting. So again, something about this. 17, 18, 19, okay. We're getting like, is there any pattern we can see here? Don't see anything. There are one. It's this thing again, right. Oh yeah, no, that's, yeah, that's okay. I think. Yeah, because a big endian in64 is gonna have like 3 empty bytes at the beginning. And then the first byte is gonna be just like, yeah, that, and then shifted along 3, yeah. So that looks good to me. So it isn't those bytes we're worried about, it's 15, 16, so it's this, 16, oh no, sorry, 17. 15, 16, 17, so it's from here onwards we got something wrong. Let's have a look. From tbuff2, so we're assigning value to this byte here. And we've read from A1, which is that one. So we're unpacking. Have we unpacked this okay? So let's check A1 again. So we've unpacked those 6 bits from A1. Yep. That's 15, 16, 17. Yeah, so it's from here onwards that we're fucking up. 1, 2, 3, 4, 5, 6. Two bits from A1. 2 right bits apparently. So getting that, and we're putting it out into it could be the way we pack it actually. It's here, A2. We've got tests for this. I'm not quite sure. Yeah, but although we're not testing at this point, so there's probably something wrong in here. A1, 6 bits remaining in TIX1. this really quick by test one packet, here we go, and then we can actually encode it again. Although we're not, yeah, decode. We could do something like read file. So bytes.new reader d. Encode it into a writer. There we go. Okay, now we can start really fucking around with this quickly. So I think it's in here. So let's just do something really silly and go like, let's just set A2 right here to be that. And let's see what we get. Encoded, yeah, great, okay. So this is where we're going wrong. Okay. Yeah. Oh, I feel like there's another test we could actually do. We could do this. Because really right now we're just testing packing the timestamp. Or encoding the timestamp, sorry. So what we really want to do actually is like find those bytes in the source and then just do like a direct thing, which we actually can do because we know that in here, yeah, the value one is 1, 2, 3, 4, 5. Yeah, those 5 bytes. Okay, so that's what we're going to do. We're going to let's dump all of that shit, or at least that. Because this is just timestamp encoding now. Yeah, all of this stuff. So we just have a timestamp there. And we know that the value we want is actually all right, 5 bytes. It's going to be those, the ones from, so it's, yeah, X 21000377, 21000377. X 1, 2, 3, 4, 5. Great. Okay. So now when we yeah, we can really just do all of that. So first we can decode that and make sure we get that. And then, yeah, just keep iterating from there. So the value that we want is, oh, sorry, let's test decoding first. Oops. Oh yeah, I want that. Yeah, that's right. Cool. Okay, we can delete that. And then our packed one is this can actually just be timestamp. We don't need to do that. And unpacked, so was unpacked, but what we want is 1. There we go. timestamp returns two values. Error. Pack timestamp percent v. Unpack type of, oh, whoops. Oh, that's the pack timestamp of the equals packed. Yeah. There we go. There's that bug right there. Okay. Then we could actually do that in binary because there's a whole lot of bullshit going on there. Actually, we can just do it in. That many bytes. Okay, there we go. That looks good. And actually, we'll do 08 just to get every single one, every bit, because every bit is important. I'll do it. All right, there we go. Okay, there's our problem. So we got a 0, 1, 2. Okay. A 1. That's it. After all that was just some bad testing. So we got ticks. Yeah, because in our array, yeah, it's 0, 1, 2. Okay, so 0A, 0, 1, 2. Okay, so this is the problem here. So ticks 1. Okay, this is our. We've read. Here is just 1, 2, 3, 1, 2, 3, 4. Mm-hmm. Looks really wrong. Damn, it looks fucking wrong. Anyway, it looks like super wrong. If we read A0. Yeah, well, anyway, no. We know those are correct, so let's go to A2. Oh. Okay, so the ticks that we're reading are from 1 and then those 5-bit, these 5. So apparently we've packed ticks 1. We've done those 3 bits out of here. So now we want to pack those into A2. Because A1's all packed up. Okay, so let's do that. So A2, B equals ticks. One, 2, 3. That seems okay to me. B shifted left to the 3. Something up here. It's up here, isn't it? Because because this is just 0. And that's just 0. 1, 0, 0. Yeah, no. This is all wrong up here. I don't think we're getting this correctly. Let's print out this. One, 0, 0. What the hell? 1, 0, 0. Just didn't see that anywhere in here. 1, 1, 1, 1, 0, 1. 1, 1, 0, 1. 1, 1, 0, 1, 1. Oh, and then oh yeah, there's a check bit in there. And the check bit. And then 0. No. 0. 0, 0, 1, 0. 1, 1, 0, 1. Yeah, okay, so we're doing, yeah, all right, let's fix this up. So we're gonna do 0, 1, 2, 3. Reading in a, like the thing that we're reading is a 33-bit integer. So we can only ever have 8, 16, 24, 32, 31. Yeah. So that's right. So we're getting rid of ticks there, which is good. Like we're skipping, so we're slicing off these 1, 2, 3, so that we only have those. So we start with ticks O and B 0. That's 0, so we can't test it, and the same for ticks 1. Because this is ticks 0, ticks 1 is also 0, so we can't even test that. I mean, we don't care right now anyway. Oh, got it. Look. Ticks 1. Yeah. This is ticks 2. Is that fucking annoying or what? Alright, so because we've read from, we've already read all this information. Yeah, so this is ticks 2. And then we've read that 3, 4, yep. And so when you go to 3, 3, 4, maybe. Okay. Zero. No, let's get this right. 0, 1, 2, 3 onwards. So it's 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4. Okay. 0 is there. 1, 2. Oh, we've missed a bit here. So when we pack it up, we've got this wrong as well. So we've got A 0. I don't think we're checking. Yeah, that one there. So we can read that from, hold up. Oh, maybe that bit doesn't matter so much, but ticks 0. Let's read the first bit. Okay, done. And then we read 2 bits from A. Yeah, we read 2 bits from ticks 1. It's there. And we shift that along 5. Here, 1, 2, 3, 4, 5, yep. Okay. And then we can read 6 bits out of ticks 1 and put that into A1. Well, that's not right. We want to put it into A. Tick 0. No, that isn't right. There's a pack remaining 5 bits, no. Yeah, there are 6 bits remaining in ticks 1. A1. How many bits have we read? A1. Ticks 1. And ticks 1. A1. Yeah, that's about right. Okay. Then ticks 2 is done. Ticks 1 is done. We're done with ticks 1. From ticks 2. 3 bits remaining in A1. I would say that's actually 2 bits remaining. Because we've put these 6 into here, so we've got 2 bits remaining. So then that's two bits from ticks 2. Ticks 2, pack the leftmost 2 bits, that'll be these ones. So we're going to pack those into here. So this is wrong, that's 0, and then that'll be shifted to the right 6 then. Okay, A2 now. A1 is all packed up. Yeah. Yeah, that's where we're at now. Just found a bug with the timestamp encoding. So when we pack the timestamp, it's not quite right. Actually, it's super not right. Yeah, and my brain's super fried as well. I'm like, well, but I just really want to finish it, and then I'm good. But my brain's absolutely fucked. So right now, yeah, A1, A2, 3, 4, ticks. I'm getting something wrong with the ticks here. Ticks 3, ticks 4, 4. That's 4. And this is 6 bits. Yeah. I can see yeah, hold up. Let me get that. Yeah. There we go. See, look. I got it. Okay. Rubber duck. Okay, Mr. Rubber duck. Okay. I just had an off by 1 on my positions here. Right now I can see everything's correct, but I'm one position. I need to shift everything. So I need to go through and just make sure. So yeah, that's right actually. Yeah. Oh no, I'm packing the timestamp. So I have a timestamp that is okay. The timestamp. I will show you a timestamp. That's our timestamp structure there. I'll put this over here. And what I'm doing is packing that structure into this one. So I'm slowly making my way through. And here's some kind of code to do it, I think. Yeah, exactly. Yeah, encoding. Yeah. So flags are toggled okay. Those are these ones up here. We're setting the check bit okay. And yeah, and so then from there, hey, this is running OpenBSD. And yeah, so, oh yeah, lots of fun. That's a nice question. Yeah. I mean, the operating system is pretty boring, if that makes sense. But it's kind of, that's kind of nice. So it's fun to learn about. It's not very fun to use, if that makes sense. I only use OpenBSD. I've also got a Mac as well that I use to do like the video stuff with. And then, yeah, and then that's it. Oh, and every now and then I'll use Plan 9 actually. So yeah, that's if I'm feeling really crazy. Yeah. Okay, so what we got here is two bits remaining, yeah. And then so here's our ticks down here. So we've read that first bit, and then, okay, let's go on to where the problem is. So we're there. So that's A0, 1, 2. So that's here. See, I think I see it already. Because we've read these 2 bits, right? So we've missed one. So actually, we want to read the remaining. We're done with ticks 1, so pack 2 bits remaining in A1. Yeah, this is, so pack remaining 6 bits from A1 into A2. And then that is going to be shifted 1, 2, 3, 4, 5, 6. No, that's 5. Okay, so A2. Sorry, no, A2 is here. 1, 2, 3, 6. There we go. And now this is now we only need 1 bit from here, actually. And flipped it around. Yeah, there there was bugs with that too. That's the thing. Yeah, exactly. That is exactly my feeling. Yeah, exactly. Yeah. But we're good now with that. Like, it's all good. Yeah. Yeah, there was. I can't remember. I can't remember now what it was. I only fixed that just a little while ago. But we're all good. We're all good. Okay, it's this bit. So I just said it here, right? So we've read A1 is all packed up. Okay, great. So let's go to A2. When do we start working with A2? Ticks 2. Pack left to it. Ticks 2 into A1. A1 is done. Pack remaining 6 bits from ticks 2 into A2. So 1, 2, 3, 4, 5, 6. I want to pack those things. It looks like we're doing that okay. And ticks 2, if we've pack remaining 6 bits from ticks 2 into A2. Okay, we're done. Ticks 2 is done. There's only 1 bit remaining in A2 before the check bit. That's that. So pack 1 bit from ticks 3 into A2. That's it. Okay, so we only want 1 bit, and ticks 2 is done, so that means we do this. We only pack 1 bit, and then we go and we shift that along 6 because we want to put it into here. Nice. Done. Okay. Okay, here we go. Here we go. This probably makes sense. Now this is 6-bit. No, there's not. There's now 7 bits remaining in ticks 3. A2 is all done, correct. Ticks 3. We want to read 7 bits. Can we read 7 bits in? Yeah, we can, because we're going into A3. That, and then shift it along. We've never touched it, so that's that. Okay. Ticks. Yeah. Ticks 2 is done. A3 only has 1 bit remaining now. So we are going to read 1 bit. Ticks 3 is all packed. So we're going to read 1 bit from TIX4. And then we want to pack it into a 3 all the way at the very end. So that's going to be shifted to 7. Okay. A3 done. Okay. 6 bits remaining to pack from TIX3. 7 bits remaining. So which is that? And then we're going to do that. There we go. And then we're done. There we go. Oh my God. Oh my God. Nice. Okay. Finally got past that bit. Oh, that was such a bitch. That was a bitch. Those timestamps. Just so fiddly. Like, look at this shit. Like, this is terrible. Look at this. Oh, God. Okay, so there's got to be a nice. I mean, I feel like there's stuff that I don't understand about binary stuff that I can like. Working 1 byte at a time and testing that. Yeah, yeah, I think so. Yeah, 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 absolutely. Yeah, because I lost a lot of time there, like trying to work out which byte. Because I was doing an end-to-end like byte check and the value of the bytes were different, and finding out which byte that actually was just took fucking ages. Yeah, yeah, having regrets from the other day. Oh man, that's yeah. I had when I wrote this, I actually had another test. I've got another test already. Was it yeah, in this one. I had this. But I was only testing the extremes. I was testing the maximum ticks you could have and 0 ticks. So here I should put in my the one that we've just added. So now I can do true, true, and then the value here I know is 90, well, whatever it is, so 90, was it this one? Yeah, here. And then here is going to be 5 byte, and then it's going to be, well, just all of that, yeah. Now I can actually annotate this because this is from this is from 19, whatever it is, there, from that file. And then in theory, I can, yeah. Then if I have, yeah, so that's where it is. We've got 0, you know, 0, I mean, probably start with 0, but anyway, whatever. Yeah. So that's already much better. So let's get rid of the, there we go. Whew. Wow, okay. That's going to be really interesting too. I mean, what are we? We're like 7.5 hours in now. Yeah. Oh, this is going to be a very boring YouTube video. Wild. Highlights, reaction shots. Yeah, exactly. Yeah. One hour edit. 1 hour. Try fucking like 15 minutes. Oh yeah, no, yeah. Yeah. And then like fucking yes, and then just straight away afterwards, oh fuck. It is, because that's pretty much what, like, you know, because when I did get the timestamps packing okay, I was like, fucking yes, you know, this is great. Yeah. 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 Yeah, they're kind of looking the same. Yeah, that's exactly. So here's, yeah. Got a little bug there as well, actually. I'm pretty sure that's in the presentation. Yeah, look at that. See, so we've got another bug that we need to test for. So we could actually, okay, let's see if the testing that we've set up is actually like working. So if we go to packet, 163? Okay. And we can just go to where it's reassembled and we can say, here we go, there it is, bang. So, yeah. Okay, so 210039. Okay, so let's get that value, 21. Packet, what do they want? 163. And the value is tricky. So the value is going to be, what's that, 10.3 at 162. Times 90, 123. Okay, so that's, it doesn't quite fit, so maybe 9 through, maybe 6. Okay, and then the hex value is going to be 210039. Okay, so OX 210039 8395 8395. Wait, what? 95. How do you do 9? What? What the fuck? those are the bytes there. So that's 0x21, yeah, 00. 0x31, no. 0x3, 1 and 001. Oh yeah, it is 9. Yeah, fuck. Oh my god, I'm my brain. My brain. 8395. Okay. Let's just do this one specific test and start powering away at it. Alright, there we go. Okay. Oh, okay, this is wrong. So this one is actually, oh, hold up. This has only got, yeah, no, hold up. Okay, this is actually wrong. So this is false. And this is false. There we go, yeah. Okay, all good. All right, so timestamp, pack timestamp, 22934 equals 21371, blah, 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 blah. Okay, so it's only byte 4. Okay, so if we go to our, okay, oh, it's a feature film, encoding MPEG timestamps, peaks and valleys of the human experience. Oh, I'll tell you what, there are some, this is a fucking, like, these are ups and downs, like, peaks and valleys. I mean, damn, this is like peaks and like deep gorges that we're going down. Deep like peaks and like down into the under the ocean trenches, Mariana Trench or something of human experience. Okay. 100, we'll get there. Yeah, no, actually, no, like we're actually super close now. Keep it up. There you go. Thank you. Yeah. Thanks for the good times, man. Okay, pack timestamp. So byte 4 of the timestamp. 0, 1, 2, 3, 4. Interesting. Huh. 1, 0. Huh. Might be in the dec. 0, 1, 2, 3, 4. It's just in that one. Let me check that we're getting the right value. Hexadecimal, so the timestamp. 8395. Yeah, absolutely. Okay, so we're getting that. So that means we've got the, oh, that's better. After this, I'm done. Oh, it's 10 p.m. here, man. Okay, yeah. No wonder I'm fucked. 7 bits remaining to pack from TIX3. Let's have a look at this. TIX. That isn't correct. That's backwards. So I'm going to delete that. This is the correct. So the byte index 4 in the array is wrong. Just by a little bit. Only a tiny bit. That 1 bit. Ah, so shifts at 7, isn't it? Yeah, that's it. Yep. Because it's that 1, 2, 3, 4, 5, 6, 7. Yeah, and then you check the, then you toggle the check bit. Ah, okay. Nice. But, oh, weird. Byte 16. Of packet 163. Four, 0, 1, 2, 3, 4, 5, 6, 7. Oh, that's 4, 7, 14, 15, 16, 9, 5. 2, 1, 0, 0, 3, 9, 8, 3, 9, 5. Weird. Encoded 82. Oh, weird. Hmm. 8395. Wow, that's really bizarre, right? So like I'm testing for that specifically here. You know what? You know, that'll be me decoding it. So this is probably wrong here. This is decoding? Yeah. So this is unpacking it. It's up here. Okay, let's look at this. So now something happening at that index 0, 1, 2, 3. So A3 involves bytes index 6, 3, and 4. So it's those ones there. So something wrong there, perhaps. And by the looks of things, it's that. Because wouldn't that have to be... All right, let's have a look. Okay. So tbup, this is decoding it. So tbuff4, 3, 0, 1, 2, 3. It's gotta be 7. No? Oh, okay, maybe not. Is that check bit? Maybe. What's that? 0011. A2. So the array in this case is this. So A2. So we want to read the 1, 2, 3, 4, 5, 6, 7. Hold on. A2 has got 7 bits of information in it. Reading that 1, 5, 6. Oh, what? Oh yeah, no, that's right. Yeah. Yeah, that feels okay. Yeah. I've already read everything from A3, 7 bits. Oh, so close, so close, so close. Okay. A2. A00. Yeah, we get that. Nah, it's just here. It's that byte. 0, 1, 2, 3, yeah. It's just that byte there. A2. So the value there, that bit, is going to be assigning that to tbuff3, yeah, and then all the way over, yeah, okay. And then we get this thing, A3, all of that. So that's going to be 7. So we've read that one. Okay, so now we're going to read, we've read 1 bit in. So we can read 7 more. All of that. And then we unpack it into there. So this is 1, 2, 3, 4, 5, 6, 7. Yeah, that's right. So maybe there's something going on with the encoded OX82. Oh, hold up. Are we just missing a check bit? 0, 1, 2, 3. No, we're not. No. It's just that bit there. So that, sorry, no, not that one. No. Encode, oh no, sorry, yeah, byte 16. 0, 0, 0. 0, 1, 2, 3. Yeah, it's this one. Three. Yeah, it's that. Yeah, it's that bit there. For some reason, we're not getting the value I expect. So let's check in this encoding again. Ticks 4, is that correct? Yeah, ticks 4. Oh. This is there, that's it. Ticks 3. Oh yeah, ticks 4, yeah. Ticks 5. Why does this feel wrong to me? 3. I can't get that again. Fuck. This still seems wrong. Just wrong. Top of the check bit. Okay, good. So then it ticks. Yep, we've got all the ticks there. Okay, so ticks 1. Yep. One, 2, 3. Hey, how's it going? 3, 4. A3 has 1. Long day and it's only 1 PM, yeah. We're so close to packing the this timestamp structure into this bit field. Just off by 1 bit, and yeah, that's it. Just 1 bit. Every time. Yeah, again, yeah. So that's it. It's like I'm just not toggling that 1 bit correctly for some reason. I can't quite work out why. Is it this? 1, 2, 3, 4, 5, 6, 7. Should this be 3? It's in this, no, sorry, it's that bit there. So in this case, we're packing A3 What's this? Don't want unpacking that. Yeah, it's this here. I'm off. I'm just off. That's why this should be ticks 4. Where am I going? Ticks 1 here. Ticks 0. Yeah. 1. That's correct. Should be 5. Yeah. That bit. Yep. And then we go 2. Yeah. 1 1 2. Yep. 3. Oh, hold up. I didn't. 0 1 2. 0 1 2 3. Nah. Almost. 6. A1. A1 has no, yeah, okay. A2 is done. A2 is done, okay. So we've read B. Seven bits remaining from ticks 3. Pack that into A3, so we put that into here like that. Now we go yep, ticks 4, okay. Ticks 4, A3 has 1 bit remaining. Yeah. So we get ticks. Oh. No. 3. Ah. Hold up. I pack. I think I just found it. Ticks 2 is here. So pack ticks 2, 2, 3, 4, 5, 6. Okay. Into there. Yep, so we do that bit into there. Okay. Now we've got ticks 3, we've got a few more. So now we can do ticks 3 directly into A3. Ticks 3, yep, into A3. Shifted 1, yep. Okay. Ticks 3 is all packed, yes. Okay. Ticks 4. We can get. No, that's wrong here. Ticks 4. ticks. Okay, ticks. Yeah. 1 bit remaining from ticks 4. Yep. Okay. Oh no, this is it. No, wait. Ticks 1. That's ticks 1 done. Ticks 2. 3. 4. 5. 0. 1. 2. 3. 4. 5. Where the fuck's that extra bit? One bit. Put that into there, and then 1, 2, 3. Then 2 bits from ticks 1. 2 bits. And then we shift that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 positions. Yep. And then finally we toggle the check bit. Okay, cool. So we've done all that. Okay, now we'll move on to this. So we've got ticks 1. Blah, 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 is A1. Yep, and that. Okay, ticks 2. Wait. Yeah, now we're up to ticks 2. And we've got these 2 bits left. 2 bits remaining in A1, yes. Yep. Okay, we've got two bits left from in A1. We're doing that here. Okay. A1 all packed up. Yep. Pack remaining 6. Pack remaining 6 bits from There, that's it. Oh no, ticks 2. A3. No. 1 bit remaining in A2. So is that byte 16? Byte, it's this one. Oh, is that there? A3. I think that's right. I mean, maybe it's the decoding it. It has to be when I'm decoding it because I know that I'm encoding. Like, wait. Packed. Is that it? Yeah, it's different, yeah. array of 0. Get that bit, okay. Yep. And then those 2 bits. Yep. And those 2 bits. We got 2 bits there, and we go like there's 2 bits, and then we go 1, 2, 3, 4, 5. Yep. Okay. Next one is, and then we skip that one. Okay, so go to the next A1, and we go, we fill up those 2 bits, so we want 6. Oh. No, hold on. A1, OB1. I've read those 2 bits. And I've put them in there. Okay. Now I want to read 6 bits. Yeah, so I'm going to read 6 bits. No. I've put 2 bits and I've put them there. Now I want to read 6 bits and put them there. Yep. There it is. There it is. There it is again. Look, and then that's all it was. That is crazy. I'm just going to end the stream right there. So that is fucking funny. Programming. All it was a little, you know, that little operator, the little pipe there. That's all it was. Okay, I'm out of here. Thanks everybody. See you tomorrow or something.